maybe to get the volume a bit up.
Yeah, Alexander.
Too loud. I think it shouldn't be in front of there.
Yeah. I'm just pulling up.
Yeah, to this.
Could we have your attention, please?
You're turning it on. You're turning it on.
The light?
No, the.
Yeah. Maybe.
What?
Need to mute yourself. Because this. Okay.
All right. Can everyone hear us okay? Too loud? No? Good? Okay. In the back? Tom signaling a bit too loud? I don't know. A bit too loud? Awesome. Again, everyone, thank you so much for coming. NixCon 2022 Paris. We're super appreciative. I think there was an awesome turnaround, so thank you to everyone that came. Quick intros for those that don't know us. I'm Ron, founder, co-founder of Flux and CEO, and also Nix board member, and just do Nix stuff. And Ryan?
So I'm Ryan, and I'm an independent contributor. I'm the NS host for this place and this NixCon, and I'm basically a Nix package contributor and doing all kind of stuff around. So you may know me as Right Obesarius on Matrix and so on and so forth. And nice to meet you all.
So real quick, before we get into like agenda, this is just an opening statement, just to let you guys know what's going on. We wanted just to really big, mention a few names here that have been tremendous in helping out. There's an entire organizing team of 8-9 people. I'll call out specific names in a few minutes so that we can kind of like force them to stand up, and we'll give them a round of applause because really they did an amazing job. I will just call out Ryan. So I'm in California, Ryan's in Paris. This is the guy that like led a group of organizers here, and I don't know if you saw my tweet, this thing is a gym. So there's green floors, there's a basketball hoop on each end, there's weight machines in this, but it looks amazing. So, huge congrats to Ryan. Agenda. Sponsors.
Okay. So you want me to go for the sponsors?
Mm-hmm.
So we also want to thank our sponsors, which without them we wouldn't be making NixCon a reality. So I want to give them a big applause all. Flux, CashX, we are their Délégation Générale Numérique, it's French staff. Serocon, Numtide, Twig, Antiphysis, Google, Determinate System, Flying Circus, NixHow, WorkRound, PTT Partners, Meetwise, Mercury, RQCI, NixBuild, and I hope I didn't forget anyone. CashX, too.
Thank you for the sponsors.
Thank you.
And in terms of the sponsors, there's going to be little tables in the back. At any time, like when we have breaks and things like that, go back there. They're hiring, they have cool things to check out, they have some swag, so feel free to walk around and do that. Want to go through the agenda real quick?
Yeah, so we're going to have very exciting talks today. So first, a keynote about Nix and the Nix community, I think. I don't even know what is going on. And then we will have a break, a coffee break. So we will have coffee break at the back, like always. You will have tea too, and many drinks. So help yourself. Please use your mugs that we provided you for coffee mostly. If you need to drink juice, it's okay to use disposable cup because we try to cut down on our use of disposable cups. So it would be very helpful if you used your mugs. Then we're going to have lunch. Lunch is not going to be here. We're going to guide you to a tent in the park where we're going to have lunch there. We have all kind of diet restriction and stuff for that. So I hope you enjoy it. So please follow instruction for the lunch because we are a bit like tight on the schedule. And you have also another break, and we will have closing remarks. I think we're going to run late today, 15 minutes, 20 minutes late. It's fine because, as you can see, there is a big gap between the closing remarks and the social event. If people hear our social event and want to come to the social event, you will have to leave the venue first, do something else. You can have dinner, you can have whatever you want, and come back here with your name at least, so we can find you, find your social event ticket. I think that's pretty much it.
Yeah. Beyond that, just a few quick other things. Tomorrow, there's a hiring happy hour, so you might see some folks with green stickers. Those are folks that are hiring, sponsor or not sponsor, just folks that might be hiring. Check it out, right? Talk to them as well. That's going to be tomorrow. Saturday, of course, is the hackathon, so there is a board right up front next to the door to write down ideas and create teams. Sorry, I have some feedback.
Yeah.
And I think, really, in general, we're super excited. I think we kicked off organizing this NixCon like 4 months ago, so we're really happy that almost 200 people turned around. I think we have a few dozen people online, but Brian can probably confirm that. And 3 days, 25 talks. It's going to be amazing. Thank you guys for coming, and we'll kick off. Thank you.
Thank you all. And to end this, so I want to give a big thanks to the volunteers, so the ENS team, the volunteers who helped us yesterday, the guys from Nuntide, the guys from Twig, and the guys from everywhere for putting this forward. I mean, this conference would be nothing without them, and I really want to thank them. I also want to thank people who couldn't come, but are valuable and important person in the Nix community. The release manager for the next version of NixOS, some of them couldn't make it. I want to all give them a big thanks because we're here because they also do a lot of things for us. So thanks for everyone.
As you can see, we're, of course, semi-professional conference organizers. Give us 6, 7 years, we'll be hot-swapping presenters. By the way, while we wait, for speakers that didn't get a chance to actually get their talk proposal submitted, approved, we're checking out ways of where we can extend a virtual speaking, kind of like an extension of the summer of Nix talks, and there's the NixOS Paris next week. So if anybody's in Paris and wants to speak, or can they do virtual, Ryan? Maybe. Wow. All right. Sure. So again, I mean, you're gonna hear me too much. You're gonna get tired of me by probably the end of the day, not even day 2. So we're kind of kicking off, of course, kind of like a Nix keynote. I think just tell you guys what's been going on, all the changes. I'm sure you're following the discourse, the Twitters, the everything that we post on, but just give you a quick run through, have some questions, and kind of kick off the event in that way. We can go to the next slide, I think. Real quick, so this time I'm actually naming the organizers, and I'm going to embarrass them, but like Ryan, who's right there, you just saw him. Alexandra, who's behind the curtain. Mateus, right there. Thank you for raising your hand. If you can raise your hand, just like really, you guys deserve it. So like Brian, Gabe, Nick, Jonas, Jacqueline, Rock. I'm not sure of the full name, right? This is like a Nix problem, so I know their handle. CTEM, if you're here, I appreciate everything that you've done. Okay, and of course, Julian. Beyond the organizer team, over 30 like volunteers helped pick up things. I think we had a little like French. I don't know if it's French, actually, that's not probably right thing to say, but they left the tables outside, and 30 tables folks carried in yesterday, so thank you guys. And again, it's gonna be fun, and yeah, just to proof that this is a proof of work concept here, this is Ron and this is Ilko. So that's us. Yeah, good. And again, super appreciative of all of our sponsors.
Can you hear me? I think so. All right. So in this talk, we'll give a bit of a overview of what's happening with sort of the Nix project in a broader sense, because the Nix project is already quite old, but it keeps evolving in big ways. So we're making some, or we want to make some big changes with how the project is organized so that it functions better. Oh, so only things get very loud. Yeah, so like I said, so Nix is already a very old project. So it got started in 2003. And at the time, it was basically an academic project. So for something like the first 10 years or so, it was mostly a vehicle for writing research papers. And then a scary thing happened. People actually started using it in the real world. Yeah, we got contributors, and we got a community. And so around, I think in 2013, we had the very first Nix developer sprint in Slovenia. I think there was about 15 people, and actually most of them were Plone developers. So we sort of hijacked their meeting. So it was a very nice scenery, very sunny. So I should go back there, but I don't think 200 people will fit in this farm. But yeah, as you can see, the community has grown a lot. We have a huge number of people. In fact, some other statistics that show that the community keeps growing. So these are the last 5 NixOS releases. And every release, we had more contributors and more commits, except for 2105, that actually had the record number of contributors. But that one also had a 2 months longer release period. So I think that's the reason. Other than that, it's to the moon. It's only going up. So yeah, it's a really growing open source community, but now we're kind of getting into a new stage where people start using it more and more in the commercial context, and there are a number of VC-backed startups, and we have consultancy companies, and we have very large companies using Nix. Just to give a few more examples of how the community is growing. These are, for people who care about that sort of thing, the number of stars on GitHub, which has grown by, 50% in the last year or so.
I will actually add that what's interesting in this one is that this took us quite a few years, right? So, oops, sorry, I think I'm probably on the wrong side. This took us quite a few years to reach the initial 6,000, and then just in 1 year, we increased it by 50%, and I think in the last 4 months, that has been further increased by, I think, almost 1,000 something. So I know it's like a vanity metric, but again, like a lot of engineers, right, in the world kind of view it as something that goes on.
Yeah. So Google Trends for Nix packages. I never trust Google Trends, but that's a separate thing. This is our binary cache traffic over the last 2 years, so since the last NixCon. So it has grown from about 10 terabytes of traffic a day to 50 terabytes. So yeah, sort of a 5x in the last 2 years. Of course, firing up 10,000 spot instances that all copy some closure from the binary cache to do something. But I mean, those are still real world use cases. So, but yeah. Here's another interesting metric. So we wrote a little script to kind of mine GitHub to see how many projects there are with a default.nix or a flake.nix or shell.nix. So right now there are something like 2,900 projects with a default.nix, 2,000 with a flake.nix. So it's a big adoption of an experimental feature. And that's actually...
That's a topic we'll discuss later. But
we'll come back to that. And that's up from 1,700 in the last 2 months. So if we plot this trajectory, then it's going to take over. There's still more projects with a shell.nix. But yeah, so...
we're replacing containers in about 6 to 7 months if people want to trajectory.
Reach the singularity. Yeah, so like I said, so that's all great, lots of users, lots of contributors, but if you, for example, who might bring up that Nix is too hard to use, that they find the language too hard, or maybe it's not actually the language, but sort of all the Nix packages, idioms you need to know. So, and there is a pretty steep learning curve with Nix and NixOS. The documentation isn't perfect. The command line interface isn't perfect. So yeah, there are barriers to entry. So if you really want world domination, then there's still quite a bit that can be improved. But of course, as users or as the people who made it, it's dangerous to sort of speculate about what sort of problems we had. So that's why Ron and a couple of other people organized a survey. I want to talk about it.
So I think a lot of you saw the Nix survey. I think continuing kind of Vilko's mention of how we're expanding things, right? We're growing. We ran a survey at the beginning of the year. The whole concept behind the survey was that we've started to grow to a certain extent that we needed to have a more, let's call it, normal way of communicating with all of the users, right? And understanding what their pain points are, how we can improve it for them rather than just assuming or theorizing, or theoretically. Really, the method here was that for 8% of their communities to actually respond to it. So I'm sure this is biased because a lot of the Nix folks are very excited about Nix, but that's a lot. Took us about 80 hours to review. That was fun. And I think the key takeaways that, of course, came from it, and I think to a lot of people in this room, this is not going to be super surprising, but it's something that we can say it's backed with some data, was exactly like, number one was lowering the barriers into Nix. I think we've talked about this a lot, and we will continue to talk about this, but a lot of people have friction while trying to ramp up into Nix. I think this problem is becoming bigger as our, as our general curve of new users grow and leans towards that. So just in the last survey, 30% of the respondents actually joined Nix or started using Nix in the last 12 months. And again, as we kind of grow, a lot of that community is going to change, and we'll also talk about that later, and we need to make sure that we're able to embrace them. Documentation. So going to touch on it real quick. It's a big topic, and I think there's going to be a great talk about it. But the 3 key points that came out was onboarding, offering, was about, can we just have one place? There is a documentation team now, so they're going to talk about it a lot more than I can. Better debugging and error messaging. I think this ties back to making Nix more accessible, right? A lot of users, when something fails, they need a better way of actually understanding how that works and what they need to do in order to fix it. And then contributing to Nix. So this was an interesting one, and this is more about embracing newcomers. A lot of respondents actually came back and said that they didn't feel empowered, didn't have the confidence to actually contribute back into Nix. So I think, you know, building mechanisms that help embrace them and kind of give others the confidence to go about and suggest contributions and be part of it is going to be critical in the years and months to come. And really, reproducibility is the way. Like when people were asked, why Nix? Reproducibility. I have an interesting thought on that because I think a lot of people actually don't understand reproducibility, probably not in this room, but in general. Next steps for the survey. So this is part of our mechanism of kind of growing and setting Nix up for success. We plan to do it on a yearly basis. So hopefully next year, everyone here can participate, suggest questions, improve it, and make sure that we're asking the right things, and then of course help us get all the feedback in. Nix Foundation. So again, part of growing is we did a lot of things, and I'm sure you've seen a lot of things happen with the Nix Foundation, and Ilka's kind of gonna take that one.
Yeah. That reads Nix Foundation. It's called the NixOS Foundation, which, by the way, is always a bit of a problem what we should name ourselves. Is it the Nix project or? But that's another discussion. So it's called the NixOS Foundation, and so part of growing the project is we feel is professionalizing the foundation a bit because. So the NixOS Foundation has existed since, I think, 2015 or so, but it hasn't really done all that much. So it runs some infrastructure. It collects donations to ensure that we have some continuity in case the current sponsor of, for instance, the binary cache were to stop sponsoring because the binary cache costs, I don't know, 10,000 euros or so a month. So that's very graciously sponsored. But if that were to disappear, then we have to make sure that the whole project doesn't stop working right away. So that was sort of what the foundation did. But what the foundation didn't do was do any sort of technical leadership. So it didn't create roadmaps or set goals or hire developers to work on things. And so, yeah, we want to expand what the foundation does. So to give more active support to the community. So to do that, we first had a sort of process where we talked to other projects like the Rust Foundation.
Exit is that way. So I'll remind you guys.
So we talked to the Rust Foundation and the Haskell Foundation and a couple of others to learn from what worked well for them and what didn't. Yeah, and so we sort of made a plan to expand what the foundation does. First step for that is that we needed to expand the board of the foundation. So previously the foundation was 3 people, all of whom had limited time to work on that, so that wasn't ideal. So we decided to expand the board to 5 people that are representative of some of the biggest contributors to the Nix project. Yeah, and we started thinking about how we can run the project in a better way. So historically, we've had a lot of, the whole project has been kind of haphazardly organized. So you had people with various responsibilities like, say, running the infrastructure. So there are a couple of people who know how to log into certain machines when something breaks, but who exactly knows what to do? nobody knows. And or say the Nix project, so the Nix repository itself, so the Nix tool. Basically, yeah, there was no Nix team. So basically, it ultimately came down to me to decide what goes in, and that's a bit of a bottleneck and a bus factor. And so now we've established a Nix team, and the goal is for all these sort of crucial teams to have roadmaps and be reachable and so on. And I think you've seen a discourse post about that. Do you want to say something about the 3-month ban?
No, I think we'll touch a lot of it in the board panel. You guys can ask questions. Really, this is again part of the trajectory of us being able to grow, right? Like I think you all know other open source communities and how they're able to kind of build structure, but also set the project and the community up for success. At the end of the day, the board is here to serve the project and the community is here to serve the project. So it's like a little arrow thing, but the board is really here to serve you guys. So just building up more mechanisms that we can do that in the right way, being intentional about it, and less ad hoc. Cool. So a little bit about, again, continuing about the topic, right? It's like Nix vision. What does that even mean? Do we have a Nix vision? Where is Nix going kind of in the long term? I think, okay. I think that in no way the board is dictating anything. This is completely, everyone has the freedom to choose what to work on, and that's the whole power of the community. What is kind of helpful here is that we are taking a lot of our time and putting in a lot of effort to try and collect the macro view of it, right? So kind of be helpful and kind of give the direction that we're assuming the industry that Nix should go in order to really step up and go to the next level. Again, some of them might be very obvious and we don't want to dig too deep into them. We can later on. But first concept in terms of the vision is we all want to see Nix everywhere, right? So having that as part of the vision might seem obvious, but writing it down means that we're tying back the different efforts that we're trying to do and seeing how it ties back to actually reaching that vision or that goal. So we have listed like a few things that we kind of believe in from the feedback, from the surveys, from just everyone's different perspective. Having it as a universal build and configuration tool, hoping that every project can have a flake.nix in it, and going in that direction and what that means. And I'm sure all of you have a lot of questions on that. And that the principles of Nix itself are understood, right? Like, I have to admit, when I go out of this room and I talk to engineers about Nix, most of them don't know. And then, like, that's the kind of point I made about reproducibility. A lot of them really don't fully understand why it's valuable. So a lot of the principles that Nix is bringing, I think we're trying to achieve that as part of the vision. And of course, good user experience. This is actually a very ambiguous one. It means a lot of things. But again, it ties back to allowing people to more easily come on into Nix, use Nix, error message, like all of those areas. And the last thing is we need more input. So, we're 2 guys on stage. The board is like 5 people, but the community, again, is our power. So you're all out there. You all know much more than we do. So, like, feeding that back in is going to really impact how we go from here. Anything you want to add on vision? Cool. Next roadmap. So vision kind of leads into, okay, then what the heck do we want to try and do? And this is the next roadmap.
Yeah, so yeah, I already mentioned roadmap. So and here again, it's a bit ambiguous what word Nix means, but here I'm referring to sort of the roadmap for the entire project. So what should be sort of the goals for, well, for, yeah, for everything. And so, yeah, we also want roadmaps for sub-projects, but so kind of the big ones we have in mind, but again, we need your input, is this, yeah, empowering teams, so making sure that all the teams are well-defined and they have, you know who's in a team and what their responsibilities and mandates are. So that's sort of an organizational thing. Then on a technical level, we really need to stabilize flakes, because, yeah, we're currently in an embarrassing situation where everybody is using them, but they're officially experimental. Likewise, the new CLI is also something that a lot of people are using, but it's also still experimental. So we should stabilize those things, call it Nix 3.0, and then we can move on to some other technical issues. Obviously, improving the documentation. So we now have a documentation team since a couple of months. Yeah, there are big things happening there. And another thing that frequently comes up is the Nix installation experience. That's often a source of random failures. And so that's not a very sexy topic, but it is the sort of thing that makes people immediately not use Nix. So we need to improve that. But again, we need your input on what should be on the roadmap. And so the idea for the roadmap is that that's sort of like the Rust roadmap kind of idea of what we want to accomplish over the next year. So it should be attainable goals, whereas the vision statement, that can be, there we can go crazy, but this should be realistic. All right, I think that's it.
Yeah, and again, that's it for that. We'll go into a few questions if Brian can look me in the eye and tell me how much time we went over, but we're, okay, perfect, thank you. Again, thank you to the organizers, thank you to all the volunteers, the sponsors. I mean, pulling this off is amazing, and hopefully next year it can be even bigger and greater. But yeah, we'll do some questions and then we'll jump over to the next talk. So feel free to raise your hand. Brian's gonna run at you, throw a mic.
I'm not gonna throw the mic. If it was a cushion, I would, but it's a steel box, so no. Any questions?
Has the board considered the current supply chain security craze and how we can ride that wave? Because Nix solves a lot of the problems there, and people are reinventing the wheel.
I didn't quite get
it. If the board has thought about the whole security salsa, security supply chain, software supply chain, SBOM, and how Nix solves it, potentially riding that wave. Exactly. I'll quickly partially respond and then okay, you can probably add on. I think that's a perfect, like just a perfect example of how the community can come in and bring things up, right? Like we're trying our best, but these are things that if you come in and you're like, hey, you know, there's this thing that we can ride. Sorry for my French, but let's fucking do it, right? I think you're completely right. Nix inherently solves salsa. I've seen numerous startups raise a lot of money solving salsa with containers and all of these scanners and cool ways, but Nix kind of solves it by construction. And this is just one example of riding a wave. I think before I send it off to you, right, Stable Diffusion. I think there's a few in the crowd here. I saw some really cool Nix blogs about Stable Diffusion and how you can just spin it up with Nix. There are startups now that are enterprising Stable Diffusion. You can actually make, and we obviously know that, just it accessible via Nix without a problem. So bluntly, no, we haven't thought about it, but I think that's a really good point.
I think we have sort of thought about these things, but yeah, it's not on the roadmap. But yes, Nix is really unique in that it gives us the entire dependency graph of a system. So you can do all these analysis like you know, what security vulnerabilities are in my closure, or what are the licenses okay, or what actually went into my stuff. Yeah, there was a lot of really cool stuff we can do with that.
And one more thing, marketing team, right? We're going to also talk about team empowerment, I think, tomorrow. And maybe you've seen a post that we made. Sorry, I'm going to step away. Hopefully those are things that can be on the marketing team roadmap. And if people are excited about it, that'll be cool.
We have one more question over here.
Thank you. So it's great that you're talking about the marketing team, because that was exactly my point. I heard about efforts for making Nix like more accessible, for instance, showing it more to the public, to people who don't know about it. And some of my questions were like, is it still an ongoing effort? Is it still a priority? How do you see that in the future? Has some stuff part of it? I think part of it was, for instance, taking care of the website, but I guess it's also part of the documentation because onboarding is also something part of it. So, like, how do you see that evolving?
Yeah, so I think that's really important. In fact, so we had here the long-term goals. So quite apart from marketing Nix itself, there's the whole bit about principles widely understood. So people need to understand why, for example, declarative, reproducible infrastructure is important, and a lot of people don't. So that's really a job for the marketing team. And yeah, so that remains very important.
So I'll also add on that, it's completely right. I'm going to give a sneak peek. I'm going to talk about this a bit tomorrow in terms of team empowerment. And there was that post. I'm going to say something that I want pushback for. I think that if we had a definition of what a critical team is, I think marketing is in that definition, just like infra and other teams. So I think that the marketing team goes beyond owning the website. It's the positioning, it's the messaging of Nix. It's when someone comes and like looks at Nix, they get a one-liner and they like it helps them understand. I think we're not there yet in terms of just like one line to understand Nix. But it's like in my eyes, it's one of the highest priorities because otherwise what are people understanding? Other questions or we're good? Cutting? All right, thank you everybody.
So I'm sorry for the little bit of the delay while we try to figure some things out. It should be going better by time we're figuring some things out live. I'd like to announce John Erickson, that's going to be talking about the next store layer. And after John Erickson, there is Remy Nicole going to be talking. If Remy could already come to the left of the stage to the monitoring bridge, that would be great.
You didn't say that. No, I don't know, but I'm still trying to, Okay, great, great, great.
we apologize ourselves for the technical difficulties occurring right now. We will be continuing shortly again, so if everybody could take their seats again, that would be very nice. We will be continuing very shortly again, so if everybody could take their seats again, that would be amazing. Thank you very much. Could everybody please take their seat? Can people hear me, or are you just ignoring me?
Like people will see you and will stop you. Even as is?
Yeah.
Oh, I should mute it. Cool.
Would it be possible for everybody to please take their seat again? We are already running a little bit behind on schedule. We will continue with or without you. It's your choice on what side you want to be.
Okay.
Okay, since it's getting quieter, I will give the word over to John. Good luck.
All right. Hello, everyone. I'm John Erickson. I've been using Nix since 2014, and have been at Indian Systems, where I work today, since 2017, doing a whole bunch of fun Nix stuff. I'd also like to acknowledge Sway for having no mirror functionality anyone here knows about, so won't be using that, and we'll be glancing over my shoulder a lot, but we'll make it fun. Okay, so today I want to talk about learning the store layer for Nix. This is sort of a new thing for me. Normally I talk about some weird project I've done with Nix itself, and some various state of completion. But as this is sort of a different NixCon, as we're at this sort of pivot point, thinking about governance, regrouping after the worst of the pandemic, we hope, I figured it was good to sort of take a step back and on that theme, talk about something that definitely isn't novel, definitely isn't by me, but is sort of the basics of Nix all the way back to 2003 as far as I know. And yeah, so it is new for me, but hopefully it goes well. So why the store layer? Firstly, I've been writing many RFCs that all seem to sort of circle back onto this, along with the projects I like to do with Nix. And also, it's a point of commonality between many different things, a few of which I've listed right there. And this is a topic I'll come back again towards at the end. Also, this sort of talk I want to say is not all novel. Gabriela Gonzalez in 2018 did a longer hour-length talk. You can see it on YouTube. That's very much of the same theme of trying to peel back the curtain and see what Nix does underneath the hood. So I wanted to give her a shout out. And also Valentine on the docs. Much of the material here is actually recycled from things we and also just he's done with the docs. So you could almost think of this as a sneak preview for stuff we hope will get into some sort of manual or specification document at the end. Okay, so now diving into the material itself. Nix, you can sort of break up to layers. On the left here, I've got Nix itself, and then on the right, I've got some other Nix ecosystem things. At the top, there's the command line, the first thing you see after you download Nix. Then there's Flakes, both conceptually and implementation-wise. Sort of a design pattern batteries included on top of that. Then the venerable Nix language, our sort of JSON Lambda lazy thing. And then finally at the bottom, the Nix store. And so that begs the question, what is the Nix store? The others we're all sort of directly interact with, but this Nix store thing we can go months at a time using Nix and not really see or know what it is. So that makes it a little less obvious. But for me, I think a good way to think about it is it's firstly a data model, sort of the core of the abstract interface, and then some operations on that data model, which mainly follow from the data itself in sort of the classic Fred Brooks fashion. And then finally, various implementations of this interface that the first two collectively constitute. And since I said interface, that means the Nix store thought of as an interface is actually not the bottom layer. After all, there's these various implementations beneath it. So let's head in and do the data model. Our first task is we want to represent plain old data. Since we are a build system, that would be sources and intermediate results as inputs, and also final results and again intermediate results as outputs in all our building. At the same time, you can sort of build up Nix from first principles and say, well, no one told me what building is. I just want to know what the data is before we get how to make it. And that's a valid way of thinking about it too, if not a very user story driven one. And the first thing we have to think about with the data model is file system objects. We are, after all, trying to store a bunch of files and run build tasks for those files. And so the way Nix works today is a file system object is one of three things. It's either a plain file, which has the contents, and one bool of permissions saying is executable. It has, or it could be a directory, which is a map from file names to these file system objects, or it's a symbolic link, which is just an arbitrary path. And we have some examples of this, thanks to Valentin. So here's a hello world one. There's the root store path but at this level I haven't said store path, so you can just think of it as a directory. It has a bin subdir with hello exe inside. That hello exe would be marked executable. It also has these share man and info dirs, and those two hello.infos and hello.1.gz files. So here everything would be either the first two cases, file or directory. Here's another example where there is a relative symlink, bin directory, and then inside it, a share go bin that would presumably point inside that shared directory. And then finally, there's also absolute paths in symlinks. So this is all pretty standard Unix stuff, but I think it's good to sort of establish what our language is, because if you actually go down like the kernel source code and say, oh, what is a file system? It's sort of a never-ending answer of more complexity. So it's good we declare a little something in scope and don't worry about the rest. Then comes store objects. While we have many directories, there's usually, as we're sort of hopefully informally familiar with, a top level /nix/store/something. And these top level things are called store objects. Sorry, I think I hit the wrong clicker button. A store object has a root file system object, references, which is conceptually a set of other store objects, and a name. Now, the set of store object thing is probably not how you're used to thinking about it if you're used to this stuff. We sort of think as the store is a collection of store objects, and store objects don't contain other objects. And basically what that boils down to is we want a very easy way of referring to a store object that has all these properties. And kind of the key one there is the easy, it says memorization, but it's supposed to say memoization, that computer word that the word processors never think exists. Sorry about that. And the solution to that is we have these store paths. So the store path is just a reference to store object. But I think over the years we've gotten kind of sloppy about calling the thing that's being referenced also a store path. And that is that is sort of not quite correct. Like saying a pointer array is the same thing. See, the references and the things they refer to are not the same in general. And a store path has this structure. The name, which is the same name part of the store object before. The digest, which is, and the name is user controlled. The digest, which is not directly user controlled and computed from all the other information in various ways. And then finally the store dir, which says where it should all be mounted so we don't mix up things that are supposed to be mounted in different places. Okay, so that is the sort of core, the store object is the core data of the store layer, but we are not just a glorified Dropbox or something. We want to build things, and that brings me to the next part, which is build plans. Build plans are graphs, nodes are tasks, and these are sort of atomic tasks where Nix doesn't have much visibility on what goes inside, but at the same time, it wants it to be sandboxed so that it knows whatever craziness might be happening, those tasks are not interfering with each other. And edges are dependencies between these things or from tasks to the raw inputs, which weren't produced by any other task. And this right here, of all the slides today, I think this is the most important one to really get the heart of the store model. Other people have plain old data in other systems. Other people have graphs, but the sort of combination of our very rigid fine-grained sandboxing and a very fine-grained graph, that's what really makes us Nix. So this is seems like a simple idea, but it really buys us so much. Now, the way we want to represent a task is something called a derivation. And a derivation has this sort of structure. There's the outputs, what we want to produce, the inputs, which is a set of something, and then the sort of more Unix-specific stuff. We have a builder, the command that's going to be run, a list of arguments in the classic Unix way, a map of environment variables, and another name. The question would be, what is the inputs exactly? And so we want to reference the plain sources, the plain old inputs, but we also want to reference the outputs of derivations. For before, that's there where the back here. So we have, actually, maybe that was only at the beginning, and I shouldn't go that far. I'll definitely lose myself. So because of this, we have these two things we want to both count as inputs. How should we do that? And the answer is, at least retroactively, this notion of a drive path, which is sort of the way to address everything we can have or potentially have after building in Nix. And the drive path is either an opaque path, which is just a store path, or it's one of these build paths, which is a pair of a store path representing a derivation and an output name. And hopefully soon we will have some surface syntax for that. We already have, thanks to Elko, at a higher level, this caret syntax with flake refs and output names, and hopefully we'll be able to reuse that for this too. And so with this, we can then go back to the derivation again, and there we can now see inputs as a set of derived paths equivalent to a set of store paths and a set of these build path pairs. And this represents everything we want to represent. Realize I've gone really fast, so maybe I'll, if anyone has a question here before I go to the next bit, happy to take one.
How real is the derived path? Like, does the derived path exist in the file system, or like just in the derivation? Like, where is that data structure?
It's not in the file system. Good point. It is, and because the derived path is sort of a new concept, it's not immediately obvious if you look at the serialized form of a derivation. But it is definitely conceptually there, and it's a type in the C++ in the implementation. And once we have the surface syntax for it, it should be a little bit of a less mysterious concept, but thanks for asking. Anyone else? Okay, I'll continue. So operations. First, there is basic CRUD operations on the store objects themselves, except there's no update because store objects are immutable. And then there is building. For the CRUD options, I was worried about time. I think I might actually be okay, but don't have the slides, so too bad. Still use your imagination. There's a little, but you can sort of say creating could be creating a store object from scratch, which could be like using a fetcher or using add to store. Reading, you could imagine as copying store objects from one to the other using like the NixCopy command. And then finally, deleting, we can't delete arbitrary things, but we can garbage collect, and we can try to delete something hoping it's unreferenced. So in sort of a functional flavor, those are our classic CRDs for store objects. And then finally, building is sort of the interesting part. And here I do go into detail. So the basic idea you might imagine is before we can build a task, we have to have already built its subtasks, which means we have to conceptually replace those derived paths with the opaque paths that is the outputs. In this simplified slides, I didn't go into input addressing versus content addressing, but basically in the Nix you probably use today, this is sort of a trivial step where we know what the store objects are called a priori, but in other variations, in various states of experimental feature land, this becomes non-trivial and we don't know what the store object is called until we built it. So we actually need to do some substitution here. And then once all our inputs are built, we can build the task we're focusing on, and then we have to collect its outputs, which are in this sort of, they exist in the file system, but they're not fully registered. They're not bona fide store objects, and we have to turn them into bona fide store objects. And what that mainly boils down to is verifying and, collecting and verifying their references, which are a subset of the inputs and which must be acyclic, which isn't a problem for already existing inputs, but is a problem for the new outputs, which must refer themselves acyclically. So you can't have a out depend on a dev and a dev depend on the out at the same time. And so here are some examples. An example I did of all this. Instead of hello world, well, I want to give it a dependency. So I made it dependent on a compression library, and then I decide, well, what's a very compressed world? It's a black hole, so hello black hole. To start, zlib, as it is in Nix packages, has two outputs, out and dev. It doesn't really matter for this, but to just give you some motivating background, the library itself would go with out, and sort of extra development metadata like C headers would go in dev. So the first step is to build zlib, which has no dependencies, so we can start right away. And then it's just an easy atomic step, and we get these two outputs, and my arrows here are supposed to indicate that dev depends on out. The arrows are pointing downstream, not upstream. And that could have been either way, but in reality and in Nix packages, and for the sake of this demo, that out arrow, the arrow goes from out to dev and not dev to out and not no arrow at all. Those are all three valid possibilities in principle, but this is the one we're doing today. Then with that happening, we can resolve the hello black hole derivation, which is the substitution step or conceptual substitution step. So just as we know that the two outputs of the zlib derivation correspond to those two store objects at the bottom two boxes. That means the reference from the DRV, the hello DRV to the zlib DRV, we can replace that with store paths to the store objects directly. And that's what's done here. So just cutting out the original derivation, we don't need it anymore, is just opaque path reference of the hello black hole now resolved. But they don't count as a blocking dependency that we have to process first. And then much the same thing happens again. Hello only has a single output named out, and there it is now built. And again, doesn't have to be that way, but matching what actually happens in Nix packages, the hello one is going to depend on zlib out, but not depend on zlib dev. And the dotted arrow again represents that the single output of the derivation corresponds with that store object we just produced. And then finally we can, just as before, we forgot about the derivation we don't need. We can do that again. And these are our outputs as a result of building these two derivations with the dependencies between them. And that is it. A fully worked out example of building. Any more questions? Well, I'm hoping that's a sign I'm actually making some sense. Okay. Now the last thing on my three bullet points from earlier, I mentioned there was the data model, the operations, and the implementations. And I also at the very beginning sort of alluded to being interested in this because it was the commonality with between many things in our ecosystem. And I'm, with this last big diagram slide, going to try to get into both those 2 points. So here is Nix again, and some other projects taken sort of arbitrarily. We have Nix itself, that's the official implementation in the middle, NixOS and Nix packages off to the right. Oops, sorry, the arrow from NixOS and Nix packages is mistaken, my bad. But, and then you can probably mentally fix that. And then towards the bottom, we have some more obscure things. There's the Tvix project you all may or may not have heard of that's trying to re-implement many concepts in Nix. So I have over here their alternate evaluator, and then showing that ideally Nix packages and NixOS, they will work with any such implementation. And then maybe a bit better known, GUIX on the bottom. So GUIX reuses our Nix store concept, and GUIX also has packages using, or sorry, it's Geeks. Geeks has packages using Geeks. I'm not quite sure what they call their packages. There is Go Nix, which is also associated with the Tvix pool, and then the C++ Nix store layer on the other side. So the arrows going into the Nix store concept, as described today, would be implementations of that, and then the arrows going in from the other side are uses of that. So I try not to pick these things to bias my point, but I think it's the way it's sort of worked out is this Nix store is this pivot point, or what we might call from networking a narrow waist, where there's many different things above it and many different things below it. And I really, okay, yeah. So yeah, as basically as we get to be a bigger community and we're having much more involvement and everyone wants to do the different things, I think sort of carving out these layers and finding these sort of commonalities where even though people have many different visions for what the end user story should be, this sort of underlying infrastructure remains very unopinionated. I think it's a really good opportunity to kind of talk about this stuff as sort of a consensus building exercise and sort of finding those minimal things that no matter how big and broad and how pluralistic we become, we can all sort of agree on. So I'm really excited to sort of popularize the old venerable Nix store concept as sort of a very nice foundational concept that no matter what other fancy things we want to do, anchors everything else. And yep, thank you. That's it.
We do have time for one question, and at the very back there is one. So let me head over, Tom.
Hi, can you summarize what you think are the distinctive features of the Nix store concept that sets it apart, and what consequences that have to provide benefits that other systems might not have?
Sorry, the first part of that question, I missed it.
What sets the Nix store concept apart and makes it distinctive from other similar systems, and how does that, what are the consequences of that that give us a unique advantage?
Yeah, great question. So for newer systems, I think often having this sort of conceptual layering at all is a bit hard to come by. There is some stuff in, let's say, Bazel or other such things, but I feel like you have to dig a little bit harder to find it. So just separating our concepts into layers so you can understand everything at all, understand bits in isolation, I think is somewhat distinctive. Older systems, like let's say Ninja and CMake, also have this layering, and let's say a Ninja graph is somewhat similar to enrolled to what our like a Nix store build plans are. But on the other hand, those older systems don't have any sort of sandboxing. So I think it's the combination of the layering and the sandboxing that makes us unique. And basically the value in that is that the layering gives us the flexibility to explore many directions at once without sort of overcomplicating and bogging down the system in the way many other projects sort of die of their own growth. And the sandboxing basically allows us to stay sane as we do more things and not sort of die under a mudslide of spurious failures and other things like that. So yeah, they're really both scaling things. One scaling sort of in the diversity of ideas, and the other is scaling just in the sheer size and complexity of what we're packaging. So I think that's the core value proposition here. Thanks.
Yeah, yeah. I'm unmuted. Can you? Is this remote?
So, next up we have Remy going to talk about Nix for particle accelerators and the adventure in cross-compilation. Quite the title. Also, please note that after this we have a break. We're going to shorten a little bit because we are sprinkling time everywhere that we do not have. Just note, break is shortened, but return at 6. Return to your seats, right. Sorry. And after Remy, Guillaume Deforge is going to talk about how to convert people to NixRest. Oh no, how to convince your friends to use NixRest.
Okay, so can everyone hear me? I think it's fine. Hello everyone, my name is Rémi Nicole. You might have seen it on the slide. I don't know why I'm talking about that. This is the first time for me talking in front of a large audience, so please bear with me. I'm working at the CEA, or CEA in French, and here we do, among other things, fundamental physics research. And one of the projects I had was to create a NixOS image that's going to be run on a small part of the accelerator. And I wanted to share my experience with you, some things that went well, some things that went less well. And hopefully with this talk, you're going to learn a bit about cross-compilation, how to do it in Nix, how to cross-compile NixOS images, and how to debug some things with Nix. But first, what is cross-compilation? Because if you do not work on embedded systems, or if you haven't done some DIY stuff, well, maybe you haven't had a use case for it, so it's nice to have a refresher. And the reason we have cross-compilation is that, well, people can seem to agree on stuff, and so we have different types of workloads. Maybe you want to optimize for performance, maybe you want to optimize for power efficiency, maybe you want to optimize for freedom. And these are all the kind of trade-offs that you have when you are designing a CPU or when you are designing an operating system. And so, for example, here we have two common cases. On the left, you have a Raspberry Pi, which is whose CPU is ARM 64-bit, and who is going to be running Linux. And on the left, on the right, sorry, it's opposite. On the right, you have a macOS, which is well, we say it's a Darwin operating system, and it's an older one, so it's going to be x86-64. And both of these architectures are considered T2 in Nix packages, so they are well supported. And so we can define cross-compilation as, well, compiling a package from a given system, which is the CPU architecture and the operating system, among other things, and from a system to a given other system. And we might do that due to performance issue. For example, we have a Raspberry Pi who doesn't have the same amount of computation power, the same amount of memory as my development laptop, who is x86-64 Linux. And we might also do that due to availability issue. Well, we might want to compile for Windows, and I don't have a Windows on hand, so it's nice to be able to cross-compile for other systems. And why is it special? Well, build systems can be a bit complicated, and you have, most of the time, you have two different kinds of dependencies. You have dependencies that you need to run while it's doing the build, and you have dependencies which are going to be run well, while you are running the software. For example, you have GCC make who needs to be run while you are building the software, but for every other normal runtime dependencies like libraries or other programs that is going to be run at runtime, well, it needs to be run on the end machine. And so how do you do that in Nix? how do we define that in Nix? Because in Nix, we have some terminology which comes from the AutoTools project, which is kind of a de facto standard. You might see some differences in other projects, but this is, I think, the most common one. And we have three types of platform. We have the build platform, which is this platform where you are building the software. And you have the host platform, which is the platform running the software, the end platform, how I called it earlier. And we have also a special case, the target platform for software that generates code. Well, it's the platform for which we want to generate code. For example, if we have the GCC, the C compiler, that can be built on my development laptop, x86 for Linux, that is going to run on a Raspberry Pi, but generates code for another third system. And that third system is going to be the target platform. And so there is two very good talk on the web. There is one introduction into cross-compiling with Nix packages by Jörg Teilheim. I'm sorry if I butchered your name. And another great talk at Euro LLVM by John Erickson, who presented the Nix way of things to the LLVM packaging people. And most of the graphics that I'm going to be showing you are adaptation of that talk. And here we have an example of me trying to cross-compile htop with two of its dependencies. And we have the normal runtime dependency ncurses, which is a library which displays characters on the screen. And it needs to be run on the same platform as the platform we are using htop on. And so here we have, well, let me get the magnifying glass. So here we have the platform which is going to be running the software. And so the ncurses is going to be run on the same platform as htop. And this is not the case for GCC. GCC needs to be run on the build machine, which is x86 64 Linux. And so GCC is going to be built on x86 Linux, but it is also going to run on x86 Linux, but will generate code for the Raspberry Pi. And if you have done some packaging with Nix and Nix packages, you may have seen already those two attributes, which are build inputs and native build inputs, which allows you to specify which kind of dependency you are specifying. And so if we take the graphics again, so this is build inputs, which is kind of like saying, if you put a dependency in build inputs, you are going to be saying, well, the host platform, the build platform, and the target platform are going to be the same as the software, as the end software. But for native build inputs, well, we're kind of shifting to the left and saying that it needs to run on the build platform that generates code on the host platform of the software. And we have also some special case which you might encounter that's like shifting one more. If you need a compiler that generates code for the build machine, for example, if while you are building the software, you need to generate tools for building the software, this is kind of a special case. And you have also some very, very special cases like depth build target and depth target, which are used only in one place while compiling GCC. And figuring out why you need this is left as an exercise to the reader. And how do you actually compile stuff? Well, you have the very handy packages cross attribute inside Nix packages, which defines, which contains a lot of different platforms that are predefined for you. And here we have the Raspberry Pi 1. And from this, we can get the hello packages. And if we evaluate and build that, well, you will cross-compile the hello packages and all of its dependencies from your platform for the Raspberry Pi. And if you copy this package and all of its dependencies to the Raspberry Pi, all of its closure, well, you will get a running hello world. And if you want to know all of the systems that were pre-configured for you, you can look at the lib.systems.examples. And if your system is not already pre-configured, you can have kind of like an expert mode in which you can specify everything that defines your system. So you can specify the CPU architecture and the OS, and you can specify how you want to configure your Linux kernel, and maybe some GCC options if you want to go into some details. This is kind of a spoiler for the next part of the talk. And yeah, and now this was for singular packages. So what do you do when you want to cross-compile a whole NixOS image? Well, in your NixOS configuration, you can use the nixpackages.cross-system option, and you can, in here, pass a pre-configured system or the expert mode system. And maybe if you want to compile some packages that aren't supported in your very special system, you can also use the allow unsupported system options. And if you're interested, and from this, you can use some attributes from the config.system.build output option, and you can compile, the file system, the kernel, the init.fs, and SD card image. And if you're interested, there is a talk, I think, tomorrow called NixOS Can Live Anywhere from Linus Ackerman, who are going to talk about that into more detail. So, how hard can it be in my use case? But yeah, spoiler, it was a bit funky. And here's the context in terms of the project. So we have some acquisition boards, which are going to be acquiring data about the electromagnetic field generated by a beam. And this data is going to be displayed on a view that is going to be shown on operator to check if the beam is in a good shape. And here we have the small setup that we have on our lab. So here the ring that we have is going to accept the beam inside it, and we have a small cable inside it to simulate the electromagnetic field. And this goes into an electronic front end because of electricity stuff. Not my job. And this goes into a acquisition card on the top left. And the acquisition card is going to do some acquisitions and transmit data over the network to the view that is on the right. But what about in terms of hardware? Well, we have a board that is called IFC 1410 from a manufacturer called Ioxos. The architecture is PowerPC 64, a big engine, so the old one, if you're familiar with it. And it doesn't have any storage. I'm not going to talk into details about how we went around the no storage thing, but you can talk to me afterwards if you're interested. Here we go. In terms of software, the acquisition software is already packaged using Nix. But before we were using Yocto to build an image, and basically in the company we had a very old image that nobody knew how to reproduce. And it was kind of hard to pick up the project back up, and so we decided to try NixOS to rebuild a whole new image with the acquisition software on it. And so what we did at first was try and do a very minimal NixOS image. So this is a very minimal set of options. So we import the minimal profile, which removes some dependencies. And we configure our cross system like I showed earlier. And we said that we were going to use the latest stable version of NixOS because production and stable versions that goes well hand in hand. And so let's try to compile that. Okay, there's a lot of things going on. Am I trying to compile the Rust compiler? So on a side note, if you are trying to cross-compile a whole NixOS system, be prepared to have a lot of computing power and a lot of time because there's a lot of packages to compile. And I mean, I love Rust and all, but this feels kind of weird to have Rust code in a very minimal image. So I don't know what is going on in there. But first, let's try to figure out what exactly is not going well. So here we are trying to build our image, and I'm going to add the keep going option to try and list every packages that is not compiling. And this is the list that we have. We have the NEDL project, which is a cryptography library, which is pretty used everywhere. And we have the kexec tools, which are tools for the kexec kernel feature, which allows the kernel to replace itself while it's running. It's not really necessary, but if we can have it, well, it's nice to have. We have Linux, the kernel, which is pretty annoying if you don't have for running an NixOS image. And we have the Rusty compiler, which doesn't compile. I mean, you know I love Rust, but if the Rust compiler doesn't compile, it sounds like a you problem, and I'm not going to keep Rust if I can. So let's try to find out what exactly is going wrong. And here we have the output of the NETL build, and we have a very weird message that's saying that the ABI version 1 is not compatible with ABI version 2. I don't have anything, I haven't specified anything about ABI, so that's pretty weird. And the Rusty compiler has a similar output. And for kexec, there is also a very weird message saying that a command lag flag is incompatible with the flag MABI LV2. So already you can see a very common theme that there is something going on between two ABIs, version 1, version 2. We're going to look at that a bit later. And for the kernel, kind of important, we have some even weirder output saying that there is a assembly code that is not recognized. So I was pretty surprised to see that. So first, let's talk about ABI. So what is an ABI? So ABI is kind of the binary land API. So it means application binary interface, and it kind of defines the calling convention. For example, in assembly, if you want to call a function and the function has arguments, maybe you want to pass the arguments inside a register. Which register? Or you want to pass arguments from memory? How do you order the memory? How structures are stored in memory? Well, this is what the ABI defines. And we have, for some context, the small history of the PowerPC architecture. So it was created in 1991, so it's older than me. And the ELF v1 ABI was created shortly after and was kind of the default ABI for this architecture. 64-bit version after. And in 2014, they kind of figured out that we needed a little Indian version of it, and it was also a good time to create a new ABI, version 2, ELF v2. And they kind of designed this ABI in a way that was backwards compatible. So you can still use PowerPC 64 Big Indian with the new ABI, and the new ABI just does a lot of things better because the old one was, well, in 1995, where the development practices were quite a bit different. And if you are a bit interested, there is a great talk that helped me a lot on the also an LLVM conference from Dr. Ulrich Weigand. And so, what does this imply for us? Well, GCC defaults to the ELF v1 for PowerPC 64 Big Indian, and it defaults to the ELF v2 version for the Little Indian variant. And some projects assume that Big Indian implies ELF v1. So because GCC defaults to it, it means that you're going to be using it. And some other projects requires LV2 to work no matter if you are Little Indian or Big Indian. And so if you choose LV1, some projects won't work. And among them is the muzzle project, which is kind of important to compile statically anything. So it's a dependency for Nix, so kind of important. And if you're going to be choosing ELF v2, some projects won't compile because it makes a wrong assumption and will pass some wrong flags or some wrong assembly. And NixOS tries to do the same thing and defaults to the LV2 ABI because, well, it's the new one and it's the better one. And so we have those three projects, NETL, kexec tools, and Rusty, which makes the wrong assumption that LV1 is going to be used. And Linux, well, it's Linux is a bit weirder, so let's talk about that later. And some other Linux distribution to the rescue. Thank you to Ryan Burns for pushing me into the right direction. And some of the distributions like Void Linux and FreeBSD are trying to push for LV2 for the PowerPC architecture. And so you can join these patches and apply them to these packages, and we're basically good to go. And so with this, Nedl and kexec tools were fixed. Not rust-C, so we are still going to be looking into removing it. And so how do you do this? So first thing is we want to figure out where exactly the rust-C dependency comes from. And so what I'm going to do is that I'm going to use this little handy command, so nixpath-info, derivation to specify that I want the build time dependencies, recursive because I want the transitive dependency, and I'm going to filter and see what exactly I'm depending for the rust-C compiler. And a little bit of a weird thing, we depend on 2 different versions of rust-C. So let's try to figure out, well, the first one. And so the first one, another very handy Nix command. So I'm going to ask Nix, why do I depend on this version of rust-C? And Nix is going to be very nice and tells us that my package is a NixOS system, and I depend on Polkit, which is a daemon that authorizes some users to do privileged stuff. And the rules are written in JavaScript because God knows why. And and so this needs a JavaScript engine, which is SpiderMonkey. And the SpiderMonkey depends on a Rust project. So here is Rust cbindgen. And this is kind of weird because from the manual, it seems Polkit is disabled by default. So it's kind of weird that in my minimal image, well, I have the Polkit dependency. So I'm going to figure out why Polkit is enabled. And Polkit is enabled through the security.polkit.enable option. And so I'm going to ask from my options security.polkit.enabled which files modify that option. And it's going to tell me that, well, the udisks2 file is going to pull Polkit, and udisks2 is enabled by default. So from the manual, it says that the Polkit is disabled by default, but in effect, udisks2 is enabled and will pull Polkit. So in effect, it's going to be enabled. This was fixed in NixOS 22.11. I don't have anything to do with that change, but thank you. And so we can just set udisks2 enable equals false, and then we remove this dependency. And we can do the same thing for the other rust-C, and it tells me that, well, we have a shutdown ramfs, which we don't need. I'm not going into details on what it does, but it's written in rust-C, and it's implemented into in Nix packages, I think. And so we can just look at the documentation and disable that. And with this, we have yeeted the rust-C compiler out of this world. So now to Linux, and this took a lot of time and a lot of debugging to figure out, and this was also very unnerving because the Linux kernel had no issues building when building it through Yocto with the same version of GCC, and my mind could not even fathom that Yocto was in any way, shape, or form superior to Nix. And so I was kind of pulling my hair out and trying to figure out why the Linux kernel was not building. And I'm not going into details of what I did to debug it. Maybe I did some black magic. I don't know. And well, the culprit was the binutils project, kinda, not really. So for some context, the binutils project contains the assembler, which transforms the assembly code from the text format into the binary format. And sometimes GCC passes the wrong machine to the assembler because, bugs. And the assembler fails because it receives the wrong machine from its arguments, and the assembly code was written for the right machine, and so it gets confused and thinks that some instructions are just wrong. And the weird thing is that the unnerving thing was that it was fixed upstream, and Yocto was using a development, a commit on a development branch of NBNutils, and so it didn't have the issue. Okay, and with this, well, everything is working. So here you have a picture of my thumb and the hand attached to it and every transitive dependencies, which is nice. But what's interesting is that we have the view that is going to be shown on the operator view, and everything's working, and I'm pretty happy, and I can sleep at night. What does this mean in practice? You know, this code is going to be stored on the company GitLab, and I need other people to be interested in Nix, so I need everything to look nice and be presentable. So how does this look in practice? Well, in practice, in my project, I have an overlay in which I can say that, for example, the kexec tools that is going to be using in my system packages is the previous kexec tools, but I'm going to override its attributes and modify the patches attributes, and I'm going to fetch the old patches that were pre-applied or the empty list if there's no patches. And the patch that I'm going to be adding is a patch fetched from the Void Linux project. And I think it's pretty readable. I think it's pretty understandable what I'm doing here. And of course, I'm going to be adding a little comment explaining the situation. Project.nix file that blatantly tells you that, well, things are not perfect, but here's exactly what's quirky. And I quite like having that file because it makes everything clear about what we need to do, you know, upstream to fix things. So, in conclusion, well, on the overall, I think it works pretty well. It's reproducible, it's configurable, yada yada. You know already the stuff. And the reproducibility of Nix really isn't a myth because, you know, the screenshot of the errors that I showed you are very recent. I just went back in time to an old commit and just commented out the workarounds, and I could get exactly the errors that I had when I did the project. The code is clear, I think. I mean, I'm obviously biased, but this is what I think. And most issues arose from the fact that the PowerPC 64 architecture, big engine variant, is quite old and sometimes misunderstood, poor architecture. And also the very weird GCC BNetUtils issue, which is also PowerPC 64 specific. And things that were a bit more hard that I don't have the time to talk about it, but I needed to add a custom kernel, and well, it's not very documented on how to do that. I also needed to add a custom kernel configuration, custom device tree, and this is thing that I think could be a bit simpler and more documented. The board also has the U-boot bootloader platform firmware. And there were some bugs when you combine this with the netboot output of NixOS. And also needed to remove some unneeded file systems and grub because, you know, I don't need grub. I'm booting from U-boot and from the network. Small comparison here. So you have Yocto and Buildroot, which are two projects that are pretty known in the embedded systems community, which compiles whole Linux images for embedded systems. And basically, I think the one thing that we could improve in Nix, well, we have an awesome community. We have two matrix channels. We have the cross-compilation matrix channel and the exotic platform matrix channel. But I mean, compared to the Yocto and Buildroot project, whose entire community is centered around the embedded system field, I think we need more. I think we need more human resources, and we need more human resources to do more testing, more experiments, more infrastructure, and more systems that are upgraded into the tier list. And for the network book, well, come see me afterward. I don't have the time. Here's the bibliography. Thank you very much.
we have time for 2 questions. I will head over there first because I saw that hand first.
Hi, I have a small question. At one point you said that NixOS defaults to big endian, but with LV2, right?
Sorry, can you speak a bit?
Yeah. So at one point you said that NixOS defaults to big endian for PowerPC,
Yeah.
but with LV2.
Yeah.
But isn't big endian the LV1, like the original architecture? So why does NixOS kind of default to a mix of the two instead of?
I'm sorry, I cannot understand. There's a lot of echo, so.
I'll repeat one last time. So at one point you said that NixOS defaults to big endian code for PowerPC, but LV2, and near the middle of the talk earlier.
So let me just go back to this slide here. This one. So here.
No, I think it's a bit earlier. It was near the bottom of the slide. A few slides earlier.
Earlier was the theory.
That seems like a mixture of the two, right? It's big endian, but it's LV2.
Yeah.
Why does NixOS default to that?
Because well, that was Ryan Burns that made this change, and he made this change because some projects really require LV2 for both big endian and little endian, and this is a hard requirement. For LV1, the projects that don't work with it is because of a wrong assumption of the thing. So it was kind of the more normal assumption to
Right. Okay.
decision.
Thank you.
So I saw a few hands, and if you want to fight for it with like rock, paper, scissors, I'm all in for that. Guillaume is giving away his place.
Yeah, so first I'd like to say it's interesting to see you run into the issue with bin utils. I'd say maybe it's one of the hardest packages in Nix packages to update. I can recall one version of bin utils had been reverted like 3 times on staging. Very hard, that package to work with. I had a question about how robust, how stable it was for you to work with NixOS cross-compilation over time. If we're looking at master, then quite often there are regressions because of mistakes in the dependency specification. How was this for you on stable? Because I think you were using 0.5, right?
Yeah. So I am using stable, and I do some updates from time to time, just try to compile it, and I don't have many issues with it. I don't know what to say more about this, but
that's what I want to say. Yeah. Okay. Great. Thank you.
Thank you.
All right, we're going to go into a quick coffee break. Just wanted to mention that it's going to be slightly shorter. You'll excuse us, technical difficulties. It's not running on Nix. There are a bunch of sponsors in the back that, because of this is happening, they have things set up, swag set up. Go meet them, talk to them, but most importantly, enjoy. When exactly are we going to call everyone back? How much time do they have?
5-10 minutes.
You have 7 minutes. Get coffee. There's a lot of croissants. And can all the lightning speakers come up front? Lightning speakers? Lightning, fast, 5 minutes?
2 lightning speakers. There are definitive list for lightning talks already? Sorry? So, I'm not sure. Should have lightning talks being way
Could Daniel Baker come to the stage as well, please?
Can Wei Jiawang come to the stage too?
Good.
Working right.
It's not. Could Daniel Baker also come to the mixing console, please? Find Brian. I still do not see a Daniel Baker. There are 3 minutes left in the break.
Hello, everyone. Hi, thank you so much for taking a break. I think we're going to kind of get wrapped up here. So if you could make your way back to your seats. There will be a lunch break here shortly as well after our talks. Please head back to your seats so we can get the lightning talk started shortly. Thank you. Am I live? Just saying, I know you are trying to make a joke.
So, we are about to get started again. I know it's extremely fun to talk about Nix, but there's more talks to be had about Nix, more specifically, lightning talks. So if everybody could please return to their seats, that would be amazing. And then we can get started again. red is okay. Yes, thank you. So we will be starting on the lightning talks. The first one by Guillaume, the second one by another Guillaume. So good luck.
Thank you, Brian. It's nice to meet you all. It's great seeing so many people here in this venue, and thanks again to all organizers and sponsors. My name is Guillaume Desforges. I'm a Twigger. I work at Twig, and I've been using Nix for 2-3 years, something like that. So yeah. So I don't know about you, but I've had plenty of occurrences where I'd be with friends. They work in tech, but they're not necessarily software engineers. Maybe we had a nice ice cold beer in our hands. We were just chatting as usual, like friends do. And suddenly, for absolutely no reason, I ended up talking about Nix to them. So I've had two sorts of reaction to that. So some of them just told me to drink my beer and shut up. Fair. And the other looked at me and just like I had summoned some demon or said some unholy words like monads. So it got me thinking, why? Why do we talk about Nix? Why did I talk about Nix to them? So there are other things in life to talk about, right? Like, I don't know, surfing, going out on a walk in the beautiful forest. I don't know. So it's really a choice on my part, right? And of course, by friends, I mean people who don't know about Nix. It's cheating otherwise. So this question is my starting point. Why would we talk about Nix with our friends? So here's my theory. It's because we use Nix. But we don't just use Nix. We love it. Though sometimes I spend my whole day trying to understand why my derivation won't build, and I end up cursing the day I have met NixOS because the pain won't go away, please help. We love Nix unconditionally. And it's just that. We're passionate. We're passionate people. And passionate people want to share. We want to share this passion. And this statement is supported by statistical evidence. We're all human here. And human beings need connection with other human beings. As such, we seek for connection because it's for our own well-being, right? We're all here for this purpose. So we need connection. So talking is not really the purpose here. The real goal is to connect. And this is what it means to belong. This is why we have friends in the first place. And also, again, this thing happening here. But more generally, this is what it means to build a community. We want to grow our community. Said otherwise, I want people to care. I have problems. I'm using stuff. I don't know. I want them to care. So the hard part is, how do we do that? So for starters, obviously, I'm going to start with what not to do. Repent, stateful systems. This NixOS bootloader shall save you. So of course, we know that being a fanatic does not help. This is not what we do. A much more common case would be this one. Oh, have you ever heard of Nix? Oh, Nix is a functional language, which is super cool. It's declarative, it's immutable. Oh, you can use overlays on your packages, and with Flex, you can compose different packages repository together, and there's this and there's that. It is a revolution. In my experience, this doesn't work. So what's the problem here? We tend to focus on the specifics, the technical details, because this is what makes Nix unique. Yes, we're happy to have the Nix language instead of YAML. Yes, I'm working with Kubernetes right now. It's not a pleasure. Yes, having the realization of derivations in a read-only Nix store is great. Solves many problems with cryptographic hash is great. But our goal here, in my talk, is to make people care about it. So if we're lucky enough, it might work, but we have much more powerful tool. We have stories. Again, we are human. Humans are programmed to love stories. And this is exactly how I started this talk, remember, telling you about my friends and stuff. So when we talk about Nix, we have to think about it like telling a story. So here are a few ideas. The day I met Nix, I was working in the bar like that. The day my job was saved, I can relate to this one. My girlfriend and I met thanks to Nix. Not today, apparently. I found inner peace. Someone in this room gave it to me. And last but not least, Nix helped me become a millionaire. So if you can tell this one, I want to be in the room and to hear the story as well. So it's really just that. Be relatable, be creative. You need to pique curiosity. You need people to genuinely care. And when they start to ask the first technical question about Nix, you can tell that Nix is a functional language for sandbox reproducible builds, and you can use a flag to share an overlay to extend or override the variation. It's okay because there is a hash to identify them. Well, maybe we still need to work on this one. Thanks for your attention.
It's working. Oh, everything's working. Can you hear me like that? Yes? Okay, right. So, hello everyone. I'm super happy to be back, like physically here at the Nix conference to meet all of you. I am Guillaume Modou. I'm known as Leius online, everywhere where I am, basically. And I'm here to present you the improvements I am trying to make to the Nix error traces. I'm currently employed by Twig, and that's what allows me to work on that outside of my spare and free time. So that's pretty nice. And actually, this whole story started at Twig with someone asking a question like that. Can you help me understand this error message? Do you have any idea what's happening here? How to fix that? Where to look for the issue? I mean, go ahead, or I will explain it if you want. So what we have here is that we are calling a built-in as attribute. So we are testing if an attribute set has some entry, and that entry needs to be a string. Apparently, we passed a Boolean for that value. So the error is not at all where it seems to be. There is nothing to do with the built-in itself, but it's like with the value we passed, the built-in cannot do anything and tries to convey that. And it does that by passing the closest position it has access to, which is this one. So I went into the source code trying to understand like if we could do better, if we could improve it, pass a better error message, and you start small and it leads you very far. So if we get back to this error message, what could we do to improve it? My first idea was, okay, I don't think this position relates to the error. It should be separated. The position is about some context, but not about the error itself. So let's just drop it. I think this message is better because it's less confusing, but it's also way less useful because now we have no idea of what's happening. So let's reinstall the position that we have with some, like as a context to the error. And we use traces for that, but sadly, traces are not displayed by default. So to improve error message, I think we should display some of the traces, at least 3, or like the shortest context around it. So now we have exactly that, the error, and then one trace, which has a text. Okay, the error happened while we were calling the built-in, and now you have a proper position that represents the position where the built-in was called, and the text and the position work along together. I want to do some like lifting and trying to make things nice. I like to have the position attached to the text. Otherwise, it's sometimes difficult to tell like what position relates to which text when you have a very long trace, and I usually get kind of a bit messed with the alternation of positions and text. And now we come to the core of this PR that I'm trying to finish. It's we can add more context. And in this case, we can add one sentence that explains what's the correlation, what's the link between the position and the context we have, and the error that pops out. And it's a small sentence, but it does a wonderful job at trying to, okay, I understand, it's not a built-in itself, but that built-in has some requirement that I need to fix. So I went through the source code and found about 250 places where I could add a message. And I did that by going to the functions that usually produce an error, like for string, which means in the C++ code that at that point we need a string. When you force float, when you coerce to string, all of these functions usually can have an error because it could be that you pass the wrong type and it will error out. So for each of these functions, I require by the type of the function that the user specifies an explanation of what is happening. So that's when the error is printed, we get a proper context for it. Sometimes it's very simple, like while evaluating the first argument passed to built-in that has attributes. Sometimes it's way more complex, like while evaluating one element of the list of strings to concat that you pass to built-in concat string set. Maybe it's possible to do better than that, but for now, with the current information that is available in the Nix source code, it's difficult to do more. So yeah, there are a few related projects. Actually, there was a Nix error enhancement proposal that has not landed yet, and it's more generic than these evaluation traces. It's like about all of the Nix errors that can happen, like network errors also, and trying to make them nicer. I get both initiatives could join to make it like a super error printing device. There is the debugger that recently landed. If you have not played with that yet, it's very, very interesting. It's still a bit different because it only looks at frames, so like function calls. And this is about what's inside the built-in, like inside the expression themselves. And then there is HNix. That is the project I try to use to inspect what's happening with Nix. Because Nix, by trying to be fast, lose or like discards a lot of information that could be useful for debugging. So that's the reason why it's sometimes difficult to have proper error output with Nix, because it tries to be fast, sadly. You have to pick one of the two, apparently. The project is not finished yet because like there are still no tests and all of that code is untested. There are some corner cases that I don't know how to handle, and then there are like, I think I need more validation through concrete examples, and that's where you can help. If you ever find some strange error message or some long error message, please send that to me, and I will try to see if my PR fixes that or improves the error traces. I don't think we have time for questions, sadly, but that's it for me.
Thank you very much, Guillaume and Guillaume. Next up is Wei Zheng with another lightning talk, and then there is Daniel with yet another lightning talk. So please welcome them to the stage.
Take some time to display, so just wait a bit.
So hello everyone. Today I'm talking about something of Nix, but not on NixOS, but on the Darwin, aka macOS. There are a lot more people think that Wayland is actually imposing Linuxism, but in fact, I saw that in late 2021 we have a pull request that has been merged, which is called FreeBSD support. So if Wayland is supported on FreeBSD, so why not on other platforms? So I have a first merge request to the macOS. And afterwards, there are also OpenBSD stuffs and NetBSD stuffs. So I don't know when they will be merged. And the main issues while porting Wayland to macOS is that have or some specific macro linker errors since macOS is not imposing ELF formats. So the first two issues have been resolved by the FreeBSD pull request by introducing a package called eposhim, which has gained macOS support this August. And for the second issue, I simply use the constant that is defined for FreeBSD. I just define it again for Darwin. And for the sock close on exec, I define another constant, same as above, and you can see it. I and unfortunately, for all the Wayland applications, we have to do the same thing again and again. So the way to resolve this is to use a setup hook. So a setup hook is something that you write once, and each time you put a package in the build inputs, it'll be executed, and your package will be automatically fixed by simply adding compile flags against the eposhim library and add linker flags against it. And these features not only include the features that I have resolved here, but also other Linux-specific functions like Pi2 or something like this. And finally, after having all those Wayland applications, we still need to solve the problem of displaying it on macOS, since macOS is different. It already has a cross backend. I simply used the old composer from Bogev. He actually wrote his own composer not only for legacy versions of macOS, but also for a system which is called UHERD. And I packaged this application. It's quite easy, but the problem is that it is impure in my implementation that you will see soon afterwards. I think one of the solutions is to compile the nib files that should have been compiled using IB tools to XIB files, or inversely. But the problem is that IB tools is not open source and is shipped in Xcode, so you cannot use it freely. And the second thing is the Linux support is broken. I do not know how to solve it correctly using USEP, and help is really needed. And finally, for those who cannot see what for those who are but simply what is happening, and for all people here, I don't know if I can find a terminal here. It's pretty small, but if I launch the old compositor, I think you can see that there's an icon here, and maybe I should launch all with this. And I'm going to launch a terminal, a minimal terminal for Wayland that is called Havoc. That type Havoc. You'll see here is a window that is shown, and maybe I'll need to enable server-side decorations and put this full screen. And it's still small, but I can run a no fetch. And you can see that the WM is different from the quads. It comes actually from the package that is called all the Wayland composer. And thank you very much.
Hello. Hi, everyone. My name is Daniel Baker. I'm an employee at Tweag. and I'm going to talk to you about making Jupyter and Jupyter Lab reproducible using Jupyter with. So if you haven't seen or used Jupyter before, it's this really nice interactive web-based application. It can have all of your code, your data, and some annotations all in one spot. So you can see here, like, there's some LaTeX code along with some Python code, and you can have an output. So you have a Lorenz attractor, and then you can, have a Python file. You can also like view images. You can view CSV data. You can view GeoJSON data all in one spot, and it's a really nice application for computational research. But if you've ever used it, it's not reproducible. And there isn't really an easy way within the ecosystem to make it reproducible. But with Jupyter with, we can. And it's been around for a while, but we are releasing a new version very soon. Not like nuclear fusion soon, but like in a week or two. And the whole goal was to make it easier. We all know that Nix can be difficult. And we've got a lot in feedback that our API, our interfaces, requires an intermediate knowledge of Nix to be able to use properly. And we want to bring that barrier down as much as possible. And so that's the goal, is easy, a lot more configuration, a lot more hooks into things that you can change and customize. So like one thing for ease, we are using templates now. You run a single command to pull down the template, and you can just run Nix run, and you're good. And it should start up. It does come with minimal packages, just what you need to get going. But if you look down here in the bottom left, we're using Poetry now instead of just Nix packages so you can add packages that you want. And you just follow the same kind of standard versioning scheme that you have for Python dependencies. And rather than using Nix packages to pull the packages you want, which can be a little difficult, you can just do it with Poetry, and you're just good to go. And we're also defining some better kernel interfaces. Each kind of kernel before was a little bit unique, and we kind of standardize everything so everything looks the same, which can help you if you want to pull in a kernel that we haven't packaged already for you to just make it yourself. Or you can submit an issue, and we can help you out with that as well. So with that, hoping that everything's going to be easier, we have a few future road plans. We've got reproducible kernels, but we don't have reproducible extensions. And we want a fully reproducible Jupyter Lab environment. We want to get away from stateful as much as possible, as we all do. And so that's our next big move is declarative extensions. With this update, we have focused only on Linux, but we want to support other platforms. So like we just had earlier, we want to do macOS as well. And also, we need feedback. So we want you to use it. Let us know other things we can improve on, other things that we should put on the roadmap. Give it a try. Let us know. You can find it at github.com /JupyterWith. And thank you for your time.
Thank you very much again to the lightning speakers. Lightning talk, speed talk, it goes by many names. A few notes, quickly. I need 20 volunteers, 20 of them. Whoever wants to help, move some stuff around, gather at the back, please, and we'll come fetch you. I'm getting the sign of strong. Also, we're having the lunch break right now. Before going to lunch break, however, please disinfect your hands. There are stations scattered around the place. Disinfect your hands a little bit. If there's questions for the lightning speakers, Ron has created a Discourse thread where you can ask the questions, and lightning speakers can check them out and answer that way. Am I forgetting anything? I'm forgetting one thing. Probably not important then? Yeah, so have a nice lunch.
Well, I think we're really excited, but you may have noticed we're slightly behind schedule. So instead of jumping into the fireside chat right now, we are going to introduce Jade. Thank you, Jade. And then we should be able to switch over to the board fireside chat shortly after. So thank you, everyone.
Okay, testing. Yeah. All right. All right, hello, and I hope you're having a fantastic NixCon. So today I'm going to talk about debugging closure sizes graphically. So for context, I am a computer engineering student at UBC in Vancouver, BC. I'm from Canada. And I'm currently on an internship working for Mercury, which is a company offering banking for the unique needs of startups. Note the disclaimer. We use Haskell, Postgres, TypeScript, Nix, and many other things. And I work on internal tools for risk management. So disclaimer, views represented in this talk are not the views of Mercury, they're my own. So what is closure size? So closure size is basically the dependency, the size of your thing and then everything it depends on. And that is transitive. So everything that it depends on and everything that that depends on and so on. And so the major cause of closure size generally is accidental dependencies, although it can also happen that you're just putting too much stuff in for no reason. Like say you're leaving build products in. So how do you create a dependency? So this is Sally, the suspiciously sentient spaghetti. So if you depend on some spaghetti, like consider the spaghetti to be a stand-in for your choice of compiler, build system, language runtime, anything that you don't mean to depend on, but which is very large. And so you include that in your build inputs because you need to use it to build your product, but then you don't necessarily use it at runtime. And so in order to cause a runtime dependency, you need to go put the path of your pile of spaghetti into somewhere in the out directory. So literally the way that dependencies work in Nix for runtime dependencies is that it will literally grep the output directory for the hash part of any store paths of your inputs. It's crude, but it works. And so this is the resulting dependency graph. Your app now has a runtime dependency on a pile of spaghetti. So the problem with these large closures is that every time that you use your app, you need to ship around the spaghetti. And this is obviously problematic because you're just shipping around useless bytes. And this is somewhat of a unique Nix issue that this happens, but the alternative is being too careless with your runtime dependency design. So say you have your little container ship with your little container, and you're shipping around this big pile of spaghetti in addition to your app. And so this is just frustrating because it slows down pulls, it slows down deploys, and it's just generally sad. It's partially mitigatable by if you use the layered build type for Docker containers, it will put each Nix store path into a layer or like collate them together to some degree. And that will mean that often it won't actually have to fetch the ball of spaghetti if it hasn't changed. But nevertheless, it's ideal to just not send balls of spaghetti around. This also affects NixOS deploys, although again, if the path is already on the target, it doesn't matter as much. So in order to find what your stuff depends on, there's a command called nixpathinfo. There's also a previous version of this command. It's one of the Nix store commands. I think it's Nix store query. And so what this command will tell you is the size of your thing, which is this number on the left. And then it will show you the closure size of that path. But notably, even with hello, like you don't really see where the dependencies are here. And so like these dependencies are fundamentally a graph. And so like what if we look at them like a graph? There is actually functionality inside Nix store that can actually generate graph viz for these things, but it's not very good and it doesn't really give you a lot of details. So like, what if I just go like write a JQ script that goes and generates graphs out of these things and like see what happens? So I did that, and it's pretty cool. Like this is much better. You can see the actual closure sizes next to the thing, and it's showed in nice human readable output, and it's right next to the thing. But the problem is that this is GraphViz, and the problem with GraphViz is that it kind of doesn't do very good at big graphs. I seem to keep running into this. So it turns out that that this doesn't work very well when you put a NixOS closure into it. I'm pretty sure you would have the same consequence if you tried to do this with the Nix store command, because fundamentally the problem is the graph's too big. So okay, I mean, can we have our cake and eat it too? So it turns out that these large graphs are a problem in many domains, and I had this problem at work, so I built a prototype of a graph viewer, and so what if I just go put the NixOS closure into it? You can, by the way, get the graph viewer there. It uses Sigma.js, which is a library for rendering graphs in JavaScript. And it is really awesome. It can deal with very large graphs, and it renders on the GPU, and it's just great. So yeah, highly recommend that. So yeah, let's just go and build a minified version of my main NixOS config and copy paste it and see what happens. And it turns out that it doesn't actually fall over. So this is the NixOS closure. Yeah, it's ugly, but the graph viewer is perfectly capable of dealing with it, and it takes a hot minute to render, but could be worse. And incidentally, if you go look at this and you see, these look like a bunch of packages. What are those doing there? It turns out I have a package that I wrote called hsutils that has a bunch of utilities I wrote in Haskell, and the closure size is 3.3 gigabytes, which seems bad, given that it's just... Nix has this command that's really cool. It's called y_depends. And if you pass --precise, it will actually tell you exactly which files are causing these runtime dependencies by going and graphing it. And so yeah, if you use nix y_depends --precise -all, you can just get a list of these things. And if we look at this, we see that this libhsutils.so has some kind of colon separated list of a bunch of these store paths. I don't particularly know why it does this. There's a bug related to path modules that is filed against Nix packages, but I am not sure if that's the cause. Maybe it is, maybe it isn't. But anyway, I actually ran into this when I was initially learning Nix 2 years ago, and I just have a patch where I more or less did the solution to this. So why did Haskell put that there? So that filed as well, because it's been there for a while. So enough of Haskell, time for something practical. This message not sponsored by work. So I was packaging this budgeting program to run it on fly.io because, fly.io is pretty cool. And I wanted to figure out how to build a Docker image for it with Nix. So I did that, and then 219 megabytes. I don't want to ship that. It's just some JavaScript. How bad could it be? Well, let's get out the big guns. So we go and copy this closure graph. And if we go look at the result here, we can see, there's the program, which has 568 megabytes of closure. And then you see this actual sync modules thing that seems to be exactly the same size, or approximately so, which seems suspicious. And then what else is in here? Python. Why is there Python? This is supposed to be JavaScript. Where did it come from? Who knows? So if we go and look at okay, well, what's attached to this? We go look at Node.js. Node.js depends on Python. Why does Node.js depend on Python? What went wrong here? So yeah, we have this identical thing to our code. We have Python. How did this happen? So Well, Python. So what happened here is that Node.js has this rather obsolescent and extremely poorly named build system called generate your products or projects in order to create C++ extensions, which happens to be used by bcrypt and better SQLite and some other stuff that is used by the by actual budget. And this unfortunately named build system was inherited from Chromium, which no longer uses it. So it was one of the blockers on Python 2 and is otherwise not good. So like, generate my projects, I don't want that. So it turns out that Nix packages actually has a version of Node.js that does not depend on Python, which is pretty good. It's called Node.js Slim. But we do actually use this build system to build the C++ extensions. So the solution here is that we probably want to replace we want to build it, and then we want to replace it with the Slim version of Node. And so, well, and the other is we use the actual server thing depend on actual sync modules. And Nix will tell us that it is because there's this thing, which is a symlink, to actual sync modules. Okay, but like, what's the symlink doing there? Like, what's in this symlink? And, you know, if we go and look at what's in the symlink, then ESLint, prettier, TSC, TS server, does not sound like runtime dependencies that I care about, to be quite honest. So clearly it's doing something unhelpful at the very least. So, like, I don't know why it did this. It seems like every time that we see closure size problems, it's just because of absurdity. Like, you know, why? It's always something completely pointless. And so in order to actually fix it, our goals here are, one, getting rid of Python, so using Node.js Slim, and fixing the app being included twice. So we have a demo. All right, so we're just showing the initial one. So the initial closure size, and this is the number to beat, is 568 megabytes. And we can see in there that, you know, it depends on SQLite, and that's reasonable. So, okay, the first thing that we're going to do here, so this is the derivation for building this actual server thing. And it imports horrors beyond comprehension.nix, which is the part where it actually does the building of the native modules. And that is uninteresting to the closure size stuff. And we also use don't strip because it is a waste of time to strip JavaScript binaries. And there's some other things, but it's largely not super interesting. So the first thing that we're going to do is we're going to add a dist phase. So this is run late in the builder, and it's useful for doing fix-ups, which is what we're doing. So we're going to add that. And then in that dist phase, first we're just going to delete the symlink that we have accidentally added that we don't want. And then it turns out that not only was that symlink pointless, it was also wrong. So what? Video playback aborted due to a network error? How is that possible? It's running on localhost. Like, why would this happen? I mean, I know that the python-m http.server is not the best thing, but anyway, we're just gonna go and fast forward past that. Okay. Okay, that's fixed. Yeah, so not only was it pointless, but it was also wrong. It turns out that like the symlink was not even going to the place that it should have been going in order for the app to actually work. So that's kind of not ideal. Okay, so the next thing that we're gonna do is we're going to don't patch shebangs. So the way that Nix deals with shebangs of various shell scripts or scripts in any other language is that they use shebang user bin end and then the name of the thing. And so this works, but it doesn't work when you want your things to be actually hermetic and not look at the path. And so in order to make these scripts work, you go and patch these shebangs so that they point to the exact path of the thing that they're trying to call. And so that's one of the stages in the builder that's often done. But in this case, we don't want this because we largely don't care about the scripts. So you just want to like turn that off. There's only one script that we actually care about. The other thing we're going to do is we're going to remove references to native build inputs. So remove references to turns the hash part of a Nix store path into A's. Like it just breaks them, which is great when they're pointless. And then the last thing we're going to do is we're going to stick disallowed references in. So this is going to say, my derivation cannot depend on Node.js 16.x, and if it does, you should throw an error. And disallowed references is actually a somewhat questionably documented property that Nix itself looks at. So then we're going to actually try and build this and see that it's going to go awry because it does actually depend on Node.js 16.x because of various things in dependencies. And so the various dependencies have their little maintainer scripts things that they've put in there, and then Nix has dutifully gone and patched shebang them, even though that we don't patch shebangs true because it patched the shebangs in the when it was doing npm install, and so these shebangs are patched anyway, even though we didn't do this. It's really I had so much fun while initially figuring this all out. But regardless, then we're going to go and delete these shebangs. So the first thing that we're going to do is we're going to manually patch the one of these one binary that we actually care about. We're going to use sed, which is basically the same thing as ed, which is basically the same thing as x, which is basically the same thing as vi, which is basically the same thing as vim, to change the first line of the file to a direct path to Node.js slim 16.x/bin/node. And then we're going to go look for all the executables in our dependencies and go and delete their shebangs. So, and any other references, because there are some other references. And then we're going to go and copy this thing. So now we've made a closure graph, and so we're going to open another one of the graph viewer and see where we've got to. And now we see, one, we don't see ourselves there for no reason, and two, we're down to 324 megabytes from 560. So that was achieved by, to reiterate, deleting references to the full fat node that includes Python for no reason, and also not including our own source code for fun twice. And so here you can see, actually, there's another one that's like, what's this doing here? And so for some reason, OpenSSL depends on Perl, if you haven't seen this before. And the reason that OpenSSL depends on Perl is because there's a currently open Nix packages bug that is essentially stating that one of the scripts included with OpenSSL uses a Perl shebang, except no one uses the script. So should it be deleted? I don't know. But that one's a 88 megabytes that you could just, I mean, it's not 88 megabytes by itself because the closure size there includes everything that it depends on, like glibc, so it's probably like 40 megabytes, but still, that can totally be knocked right out. And so that's kind of the end of the demo. The other thing that I want to show is that the end result is that our Docker image is now 144 megabytes, which is down from 200 and some, which is significantly better. And there's just less stuff in it. And so, and also one might wonder, Jade, how did you copy things from an SSH session? And the answer is that I wrote a daemon for that. So in summary, accidental dependencies are one of the main causes of closure size bloat. It's true that putting too much stuff in the output can cause closure size bloat, but usually people care about that because it happens to people who aren't using Nix. And, shipping suspiciously sentient spaghetti slurps time and bandwidth, which is not ideal. And the solution to closure size issues is most of the time finding the references with Nix, finding out that you have a problem with Nix path info and potentially the tooling to go and look at the closures and looking for things that shouldn't be there. And then once you've found the things that shouldn't be there, you can use Nix why depends to ask Nix why is this here? And it will probably tell you that it's some reference in some kind of script, or potentially that your compiler is for some reason emitting paths for no reason. And then once you've figured out why it's happening, you can go and take action on that by getting rid of the dependencies that are causing you problems, or by replacing the path with entirely A's to break the path so that it just doesn't work if it tries to access the thing that it shouldn't. And another message is that Mercury is hiring in a lot of areas. If you are interested in applying, the link is mercury.com/jobs. They will train you on Haskell. And so that's all I have. You can get the tools that I've used here. The Nix closure graph is in my monorepo, which is somewhat mysteriously called .files. I don't know why. And you can get the graph viewer at mercurytechnologies.github.io/lookingglassviewer. It's kind of a very nice graph viewer. It takes in JSON of a very simple format to the point that you can literally write database queries that will, in one Postgres query, it will spit out the entire graph JSON, and you can stick it right into the graph viewer. And it makes it very convenient to visualize things. And you can also email me. So does anyone have any questions?
We have time for 2 questions, so.
Do you think that there are any ways that we could do any of that automatically, or like do something more sophisticated than grep for dependencies, or is it just we'll necessarily make mistakes and depend on Python?
Yeah, so the way that every other system deals with this is that it actually does it quite badly. So in most package managers and most Linux distributions, if you're writing a package and it has a compile time dependent, it just won't work at runtime. Nix prevents this, which is great, but in terms of like whether something better than grepping it is like an improvement. As far as I know, Nix itself has done fairly well with just like grepping these things. Like I don't think it even looks for UTF-16, and it's just worked, which is quite surprising that something so crude would work. In terms of something to, like if you mean to find like the cause of these unintended dependencies, that's better than grepping it, I don't really think so, because often they go and lurk in corners of files that may or may not even be parsed by tools. And so like, if it's not parsed by the tool, but Nix sees it, that's kind of not ideal. So yeah, I'm not really sure like what would help as far as tooling that would make it easier to stop this happening by accident. I think that maybe people should use allowed references more. So there's a counterpart to disallowed references, which is allowed references, and you can declare the entire set of the expected runtime dependencies of your thing. And then if you go and include that, then it will make it a build error if someone screws it up.
Since you were using disallowed references for what you were doing there, wouldn't disallowed requisites be more appropriate to disallow it in the like whole dependency closure?
Sorry, can you repeat that?
Instead of using disallowed references, wouldn't you maybe want to use disallowed requisites for these kind of things and allowed requisites as well?
I actually don't remember if allowed references works transitively. Like, if say you depend on Python, does that let you depend on glibc? I don't remember, but you'd have to check the Nix docs on that. That might be one reason. But generally, like, I feel like closure size is not necessarily something that people think of when they're building something. It's more so when it goes wrong. And maybe this should change, but like in the current sort of thought pattern of dealing with that, it's sometimes better to use disallowed references instead, just because it's easier.
Thank you very much. So we will quickly be setting up some shares. So
Thank you. Oh, yeah. Rock is taking a picture of Jonas.
Can you try again?
Test.
Oh, do we have slides for the background? We can probably get started. All right. I think it's better if you look at here, like over here.
I asked me to keep it far away. The two mics are not at the same volume.
So, guys, there's like
Are we good? Closer? All right.
But maybe if you use like that, you can still keep
Yeah?
You can just keep it.
Are we good? Are you ready for my questions? What is your mother's maiden name? All right. Again.
Either you're going to speak up a little bit or we're going to turn you up. You choose.
I need to speak up.
Yeah, a little bit louder.
All right.
Or I'm going to turn you up and then might start creating noise.
Okay, I will try to speak louder.
Thank you.
All right. Are we good? All right, so everyone?
Wait, I think we need 1 more minute.
1 more minute? All right.
We're going to find out how to make your assessment. Okay, yeah. Thank you.
All right, let's get started. So, can you hear me? All right. Thanks for being here. So today's goal here is going to be to talk to the new foundation. So the old foundation existed for a long time, and now things are changing a bit. And so the goal of here is to ask questions. I'm going to be asking questions. I have some questions from the internet, and then we're going to take questions from the public as well. So I'm just going to start a bit. So maybe for Elko as a first question, do you remember you were still at uni, I think, when you created the foundation?
No, I wasn't.
You were already out of uni?
Yeah. So no, I was not at the university. I was at Logic Blocks at the time.
All right. Do you remember?
2015, I remember.
2015. Do you remember what prompted you to create the foundation?
Basically, we needed a way to collect donations, and I think at the time we didn't have stuff like Open Collective. So we believed that we needed a legal entity for that. So we just went to a notary and drafted some statutes, and that was it.
Cool. I guess I'm gonna take next question from the discourse. there's a core theory that asked the Nix ecosystem and NixOS in particular rely a lot on volunteers and some companies investing in the platform for themselves. This leads to some necessary but toilsome work being neglected, like the security roundups, when volunteer goodwill falls behind the relentless work. Is this something the foundation is looking to improve, and how?
I think that would be great, but right now we don't really have yet the sort of the financial, what's the word, the cash to hire people basically. Maybe for small projects, but not say full-time employees. Like say the Rust Foundation really funds people, or the Haskell Foundation. So we're not there yet.
Cool.
But maybe in the
maybe
future.
you can talk a little bit about what the foundation is already doing.
I'll add some color to that. So I think while we don't necessarily yet have funding to start hiring people, we're definitely looking to structure out the way that we handle sponsorship and donations. I don't know if some of you have seen, we started to post like meeting minutes and the things that we're talking about. One of the main topics is actually looking into turning Nix and the Nix Foundation to have charitable status, which is something that we don't have right now and kind of potentially could optimize or encourage larger foundations from larger companies that are looking to get that charitable status. On the other, I think, other end of that question, while we're not yet hiring people full-time, because I would love to hire the person who gave the talk about why do you talk to your friends about Nix. While we're not doing that, we are looking to like promote and structure and empower teams to be able to do that through the volunteers.
Maybe you want to talk a bit more about what are the things you're already doing, like maybe Summer of Nix or some things like that?
So what is the board currently doing is the question. So right now we're kind of stretched out. Part of the work that is kind of blocking the rest is actually transitioning from the previous board to the new one, and legalities and all that stuff, and getting transitioning from Rob, who is going to depart the board, and transferring the accounting that he has been doing and so on. Ron has initiated the work to do team empowerment so that we are more transparent to each other, who is working on what, and kind of keeping track of meeting minutes and things like that. And just signaling to the community where there's work to be needed, which actually I think answers the previous question, where we're trying to kind of to build the structure without the structure, so that we can have people signal and call out when there's help needed in a certain team, and in the worst case escalate that to the board if there's not possible to solve something in the team. We've been working on a kind of like roadmap for that, we think is important, and the vision of the Nix project, which we will, open up and try to get feedback from you based on what we think, and, to kind of feedback that in. I'm sure I forgot stuff.
Yeah, so actually one of the biggest things that the NixOS Foundation does is that we're a partner in NGI Zero, which is this European Commission, I think Horizon 2020 project to, rebuild the internet, make everything better. And so usually, historically, these projects were large grants that could only be obtained by universities or consortiums of consortia of universities and big companies, and they were out of reach for, say, a single open source developer who is hacking on some project. And NGI Zero enables them, so you can apply to an NGI grant for, say, 50,000 euros and use that to hack on something for a year. So the NixOS Foundation is part of the consortium that supports the infrastructure for the project. And what we do is we provide packaging for those hundreds of NGI projects to make sure that they're sort of reproducible and that everybody can actually run the products of those projects. Now again, since the NixOS Foundation was only 3 people and we were starved for time for several years, we didn't really have the ability to execute that very well. So a couple of times we hired people like Jonas to do some packaging, but it was still going slowly. And then last year, we started organizing the Summer of Nix with Matthias is somewhere here, I think, did incredible amounts of work on that to let sort of patterned after the Summer of Code, the Google Summer of Code. So get people to hack for a couple of weeks over the summer, get something new out of it, and also learn something about Nix and get some education out of that. That has been super helpful. And I can mention that there are a couple of new NGI 0 rounds. So I think 2 new or 3 projects, I think for something like 10 million euros. So there are, I don't know, don't quote me on the exact amount, but so if you have an interesting idea that you want to work on, then you should consider applying for an NGI 0 grant. And so there are a couple of Nix related projects that have been done through NGI 0.
Cool.
I can add something real quick. Last statement, I promise, on this question. At the end of the day, I view it as there's tech debt, we have board debt, and we need to pay it. So, I'm kidding. Okay. So really, it's like taking all of that board debt that has kind of accumulated over the years, right, and really turning the board into a service to the community and the project. So there's a lot of things that were mentioned here that are just like, we have to get it done, right? So that's all.
So that leads to the next question I had. What is the interface between the board and the community? You know, are you gonna be influencing the decision-making process of the various projects, or are you just here to help bring the funds to different projects? I don't know.
I'll answer and pass it to Tiafon. Really, I think that's a good segue, right? The board is in service of the project and the community. So what that means for us is we each take from our time voluntarily, completely, to go and invest back into more of the macro level of things, right? Making sure that the Nix survey runs, making sure that we can create structure for team empowerment. But really the core value, the way that I view it, and I'm sure that others here on the panel with me have potentially different opinions, is that we're here to set Nix up for success, and that's a very ambiguous term that just has a lot of meaning to it. So in terms of do we make decisions? Hell no. We can't. I mean, everyone does whatever they want to do. We're just here to kind of help push it along, help answer the questions that you have, and ideally, once we're fully optimized, take your feedback and get that shit done.
I think some very important point that Ron just mentioned is that we can't be making any decision even if we wanted to, because, I mean, we're an open source community. People do whatever they want. But yeah, the thing that we can help with and that we've been trying very hard to do in the past few months is just to give the structure so that people can make their own decisions. Like the whole team empowerment work, which is just starting to emerge thanks to Ron's insistence on particular on getting the details ready, and that we're now beta testing on a few teams, are, I think, like a good representation of what the board should look like and how we should help the community, not like not doing any of the technical work ourselves, or not taking any decisions on that, but really providing the framework so that teams can emerge and people can step up and say that, yeah, I want to be involved in that project, get the leverage, and maybe like get the authority to take decisions on some or some aspect, because I'm gonna build up the expertise and the credibility to take these decisions myself.
Yeah.
The old board is me and Armijn Hemel and Rob Vermaas.
Who's with us in spirit? He's actually looking at it right now.
Are you Armijn or Rob?
Armijn is
Okay.
looking at it right now.
And so that was a three-person board. The new board is still me and Armijn, and these three guys. Yeah. So to say who I am, yeah. So I started Nix, and also in the old board. So Armijn started NixOS as his master's thesis project way back, and he serves as our secretary. Rob Vermaas is still formally on the board. He serves as its treasurer, but he would like to quit, so we need to find a new treasurer, ideally somebody who knows about Dutch accounting and tax law and stuff like that. I'll let the other guys introduce themselves.
Yeah, so I'm Theophan. I didn't start Nix. I hope I'm not going to end it either. But I've been a Nix contributor for some time now. I'm working at Twig, and well, I've recently stepped up as a board member and also board member of the new Nix maintenance team, which gives me two hats. So as a board member, I won't be taking any decision. I'm just going to empower myself to take decisions as a Nix maintainer.
I guess you work for Twig, and Armijn works for Chaldor Consulting.
So I'm Doman. I think I entered the community about almost 10 years ago. It's been quite a long time. Too late to start Nix, but and yeah, I've been NixOS release manager for a few releases, I think, and about 4 years ago I started CacheX and kind of focused on improving the infrastructure and documentation, or developer experience, if you may call it. Yeah, that's more or less it.
Hey, I'm Ron, CEO, co-founder of Flux. The kind of my background, software engineer, IDF, intelligence units, then went into startups a lot. Built a kind of like a traveling salesman algorithm for many to many, if you guys are familiar with that space. What kind of brought me closer to Nix was that my previous position was I led developer products at Facebook. So literally any product that developers used, any of our like 20,000, more than once a day, flowed through our like product teams at some level, and we were really kind of focusing on how can we introduce better products, can we empower developers and grow that, some open source, some not. Big on nonprofits, so just kind of my side hobby is I also manage the largest Israeli tech nonprofit in California, 4,000 members. I love conferences. I love like organizing these things, but Ryan is better than that at me apparently, and so is Alexandra. With that, I then joined kind of the Facebook journey, took me to the realm of developer on demand, where we built we completely replicated the iOS toolchain on Linux in order to abstract away kind of remote development. That kind of brought me into the Nix realm and into partnering with Michael. But that's my quick background. I'm the furthest from here. I live in California. Any other questions about us? Hobbies?
Any other questions from the public? Good question. So the question is, how come the board is made of these people? How did you decide on the people that were on the board?
Yeah, so we wanted something that is kind of representative of the various big stakeholders in the community. So that's have several companies, but also it represents the project as does exist for a long time. So the open source community. So yeah, there's sort of no company has a undue weight on the board, so there's one person maximum of one person per company. So that was kind of the consideration.
And I think at the end of the day, right, this might be, I don't know how this sits, but at the end of the day, we're trying to push Nix to the next level, right? I think we're all in agreement of that. We had, I think, many talks touched it, right? And I think the way I see it is ideally the board members not only have the capacity to actually fulfill and actionize on things. So obviously none of us are getting paid for this, and we're doing this while having, you know, families and jobs and other responsibilities. So we're each kind of contributing a chunk. And ideally that maybe makes a whole person less technical, but of course more on the like product and structure side of strategy and things like that. So each of us kind of, I see each one of the folks sitting to the left of me as just bringing in viewpoints and interests that at the end of the day also represent, you know, an exhaustive view and an inclusive view of the community to some extent, because we can never get to 100, but also have meaningful value in like driving decisions.
Yeah. Are there going to be elections in the future?
I think we did talk about that we want to introduce some system to that, but we haven't come to this yet. This is something we have yet to define.
Is this part of your goals to address maybe next year?
Yeah. The goal is to do this as soon as possible. Yeah. We started with like really critical things, as in things that are blocking the community, and then we will go to define these things as well.
Good. Any more questions? I think we kind of did a bit of a tour. Garbus. How to attract more funding and how to spend it as well.
So first of all, right now the problem of the nation is that we don't spend enough money, rather than that we don't attract it enough. So we have to define a bit, you know, what do we want to invest in as a community, and then we're also talking about introducing some kind of sponsorship packages that companies can donate and support Nix, and also in return gain, you know, see the transparency, how the foundation is doing and what are we investing in. So again, a lot of backlog that we have to go through.
So actually, the foundation also donated, I think 10,000 to NixCon, but I think this was the first year that we were able to actually, this is like the board debt that I was talking about, actually handle all the NixCon sponsorship from the board. Something that we had to kind of figure out and took us a while, but we were able to do that, and we intend to keep doing it. Other things that we're thinking about is what I mentioned about getting charitable status. So in terms of increasing the pipeline of sponsorship and funding, we need structure, like Doman mentioned, but we also need kind of like incentives. And we've mentioned team empowerment a few times. We really want to make sure that we have a prioritization to the teams that are, either, let's say, optimizing Nix or on the critical path for Nix, and making sure that they're funded in the way that is optimizing the entire community. But that's just starting thoughts. But again, we're happy to get feedback in other areas that are worth looking into.
Yeah, so one thing I forgot to mention, I think we have Ocean Sprint planned very soon, and this is going to be the 6th Nix event that I've organized or co-organized. But what I would really love to see is that the foundation would have some budgets to allow anyone to say, oh, hey, I'm organizing a meetup in London, can you cover the beers or, some drinks or something that, would allow the event to happen and flow. And I think that would be something within the scope of the foundation that we could, support the community from this side and also support any kind of Nix related events. Again, a lot of things to define what counts and what would be the budget and so on, but this is, one of the things.
One more question from the forum. You said that enabling teams to get the actual project work done is one of your top priorities. How specifically will you ensure that teams are supplied with the resources, like time, board decision, advice, funding, they need to work effectively?
So actually, I'm going to have a partial talk about that tomorrow, but spoilers, why not? We also made a post, by the way. We made a post, I know it was kind of in the craziness of NixCon, just like 2 days ago or something like that, where we kind of share a draft of our thoughts. To give a quick answer to that, I think it's going to be tough, because I think I don't want to be too ambiguous, and also not take up too much time. At the end of the day, we have different, we have organically created teams inside the teams have organically created themselves. And I think that we as a board, I think the question is catered to the board, have a certain responsibility, right? One is empowering the community itself to keep being a green field and keep being able to create more teams, collaborate, and do the things that you guys want to do, the things that we all want to do. The second responsibility, I think, is that making sure to recognize and prioritize which teams are on the critical path, i.e. infra team or AWS buckets, or something like if it falls tomorrow and no one can pick up the phone because that person, the only person with the access key is on vacation, that's not a good look. So I think it's two-sided, right? Empowering the community, but also providing the structure and the funding and everything else to make sure that the critical path teams are optimized.
Good. Okay, maybe last question from Payas. Some very important RFCs have been in discussion held for months, if not years. What is the plan on making this whole process move forward? Or is it something the foundation would address? Or is it separate?
That's a hard question. I think the RFC process, well, there are different sides to it. One is that the RFC process itself, I think, needs some improvements to how it was inspired by Rust, but we're our own community, so we need to figure out what works for us. That's one part. The second part is that some RFC will just not go through because either somebody gives up or the kind of there's no decision to be made. And sometimes I think the key is when the RFC gets a shepherd, it needs to be clear to the community that that shepherd is kind of like the who guides the RFC to go forward. So that's the responsibility of the person to make sure to raise why things are blocked and so on. And the last note I would say, there's often a bit of lack of authority, that people feel like they shouldn't step up and decide on something, and this is something that needs to be encouraged, and that's something that is lacking, that I've seen personally on those RFCs. And unfortunately, the answer is there is no one thing. If there would be one thing, it would be easy to solve. But again, this is a good example of creating structure and raising things to the board, and then we would try to talk to the people. If this would be made more concrete, which are the RFC, we can go talk to these people and kind of figure out what's going on and raise proposals, what could be improved in the process and so on. Yeah.
So to add to that, I think ideally the board wouldn't be making technical decisions. So probably at some point we want to have some sort of core team that can make those technical decisions that are sort of cross-cutting for the entire project, like whether to adopt flakes or something like that. But I mean, the board is not really the place to have that kind of discussion. But right now we don't really have any mechanism to get decisions that are stuck, say, in the RFC process, but that are kind of critical for the success of the entire project unstuck. So yeah, we need to figure out a way to improve that.
Yeah, to add to that, I think the RFC process is, I mean, it has its own problems, but it's something that exists in the community that definitely needs improvements, but is up to a certain extent working. And I mean, so I don't know exactly what the scope of the question was, but if the question is, should the board just chiming on a specific RFC and say, well, we as the board have decided that this RFC should pass, I think that except in a very exceptional situation, well, and I don't have an example yet, that would be going beyond what the board is supposed to be doing. The RFC process exists for a reason, and if it's stuck, then we need to help it. I mean, we, the community, need to help it get unstuck, but it's not the role of the board to just take decisions instead of the RFC process. Now, the thing I think where the board can help, like Domen said, is just support the RFC team in getting through the process and provide any kind of help that can be needed to refine that process where it needs to be. Maybe even provide some, yeah, we discussed a bit the financial matter. If I don't like, I could easily imagine a case where some RFC gets stuck because everyone agrees that it's a great idea, but no one is able to implement that. And that's also potentially something where the board could help if there's a clear consensus that that's something that would be beneficial to the community. Okay, the clock is ticking, so I let Jonas for the next question.
One more question? Okay, did I forget to ask any question or something you wanted to talk about that we didn't get to address? Yeah? You. Okay, what were some of the critical issues you had to organize the next board for eventually?
I think one was AWS buckets. We don't own them, but we need to create structure around that in order to make sure that we own that, and then we can actually mitigate and resolve any issues fast. The current standpoint, it's not there, right? That's just an example of the board debt that I was talking about earlier. In terms of, that's like a really niche example, but at the macro, I think, I hope I don't offend anyone, and of course, especially not the previous board, but I think the board needs to be here more. Right. Well, no one here is getting, well, not no one. There are companies that pay people full-time salaries to work on Nix full-time. But we don't, we're all volunteers at the end of the day. And there needs to be some sort of I don't want to say we're kind of here to do anything that needs to be done in order to support the community, but that's kind of what it is, right? So I think going back to the example of team empowerment as an example, right, we kind of expedited through that because that was a need that we felt can really help out the community and unblock some areas.
So to connect the previous question to this one, I would say I know that a lot of people are unhappy with the Flakes RFC and how so yeah, and with the
We told Brian to do that when we get to Flake.
with the new Nix team, the communication will flow, week to week, and these kind of issues can be raised sooner rather than too late. And I personally believe that a lot of these issues come from the lack of communication, and so either that would be, the community raising up issues to the board, but ideally to the team that is, part of the ecosystem. And that's a great example of, like Ron said, what we need to do and the things that we see from the community coming as issues, and put that structure into that, so that it's not just up in the air and open to whoever wants to do it, which is great, but sometimes there needs to be a bit more structure to it.
I should have a question back to the folks in the room. Who do you escalate to when an RFC hasn't passed for a few years? Right. So exactly, like we're not going to make decisions, but ideally we'll provide that escalation path, for instance, right? That kind of go to, and then we meet weekly. We each kind of even give, I would say, 10 to 15% of our time on a weekly basis to these things, and surface these things, and we're here to tackle them and see what we can do. Can't promise anything, but it's kind of what we're here for.
All right, thank you, everyone. I think we're good.
Could I call Marcus and Philip the next talk up already? Give us again 1 minute to rebuild the stage.
Yeah, does it work? Good stuff. No feedback? Huh? Yeah, okay.
I haven't checked if the video works. If it doesn't, just continue without problem. Clicker. Okay, yeah, well, you accept. Okay.
Perfect.
We're just going to start. Okay.
So we'll go on to the next talk by Marcus. Marcus, good luck.
Yeah, thank you very much. It's a pleasure to be here. First NixCon. Thank you for the organizing committee that they gave me this the opportunity here to present our work. Philip didn't make it to the conference, but I think he might actually be online. So this is maybe not your average Nix talk title. It's Nix in a scientific environment, bringing Nix together with computational chemistry. So many people are afraid of chemistry, but fear not, I don't have too many chemistry slides actually. So let's start a little bit with the acknowledgements. I'm basically a professor at Stockholm University, leading a research group in chemical physics. So I'm actually not really, my T is not my main job, and Nix is more or less of a very useful hobby to make our work possible. And what you see here is my research group in Stockholm. They actually do not really, they're not active Nixers, but they actually benefit all from a very well set up environment that just runs everything smoothly on Nix. Then, of course, special thanks also goes to Philip Seber, Sheepforce, who contributed a lot over the last 2 years to the effort of making computational chemistry more palatable in Nix. And also special thanks to Christian Kögler, who's in the audience, who actually got me into Nix. And I think without him, I would maybe sitting here trying to package apps with containers. So I got saved. I'll show you a little bit intro and background of just to give you an idea from which side I'm coming from. Then I talk a little bit about the scientific software infrastructure that is already present in Nix packages and things that we add with our overlay and try to modify. And then I also show you some kind of like anecdotes of things that we have come across over the years. Lessons learned from packaging things and all the quirks that can appear. I hope there's something useful then for some of you. So what we usually do everyday life, right? We are kind of chemical physics, theoretical chemists. So we mostly do theory and simulation, so no experiments, but we basically keep computers busy all day long at a large rate. And what I'm particularly doing is like we're doing electronic structure theory, photochemical processes, for example, you know, what happens if you get a sunburn, the chemical process behind those kind of things. We look at manipulation of chemical properties with light fields and so on, all those kind of fancy quantum things. We do ultrafast spectroscopy and attosecond physics. So this might not mean much to you if you're not a physicist, but what does it actually come down to when you run your calculations? What's the thing that you do in practice that keeps the computer 99 or 90% of the time busy? And in practice, that means you solve some kind of differential equation in quantum mechanics. And in practice, I would say that means 2 things. So either you stuff things in matrices and you do matrix operations, linear algebra operations, or you do some kind of Fourier transforms. So that's what's the main computation time in our programs, I would say. The thing relies a lot on parallel computing, of course. So you need to take parallelization into account, large-scale polarization. And to give you a hint a little bit, I mean, I would say in my personal work, we have jobs that are like on the order of maybe 50,000 CPU hours, where a single job could run that long, for example. Some of my colleagues, of course, might laugh at that and say, okay, this is small, but well, you already need a little bit of electricity to get that done, actually. So from the background, what are the problems that we're actually facing? So when I started my position 4 years ago and I said, okay, I have to run my own system, and I have to set something up that's viable and that's easily maintainable. So what are you actually up against when you look at supercomputing centers? Or in general at the landscape. So the first thing is like a lot of scientific software packages are very special, so they're not necessarily packaged. So that's why you have to do the job yourself if you really want to use it. And those things can be quite quirky, but I have a few examples on that later. Then of course, every time you talk about high performance computing, that means you have to optimize your code for the machine that you're running on, right? You run a modern CPUs that have a lot of features that needs to be taken into account. Otherwise, this is basically like running a Formula One car in the first gear over the racetrack, if you do that. If you just use maybe everything completely vanilla. Then very common in typical high performance compute centers from university is still so-called environments modules. If you have never heard of them, consider yourself lucky. It's basically a very fragile way of generate software, custom compiled software environments. And shockingly, this is very often done manually still. I mean, the community is, in the HPC community is moving forward a little bit. It's getting better, but still a lot of things is actually done manually. So every time you update your OS, most of your applications probably break. And yeah, well, how do you run your jobs? You usually have workload managers installed in your cluster like Slurm, PBS, some kind of batch queuing system. You send a simple bash script to the workload manager, and the workload manager takes care that it actually gets executed somewhere on the cluster. So, obvious solution to everyone here in the room, right? Let's use Nix to do all of that. I mean, out of courtesy, I think I should still be fair and say there's also with Gwix, there's a large effort of going on, and where this is coming into the scientific. So you need to be able to reproduce things that others did, right? If you're an experimentalist, you do an experiment, you have to describe it well enough that someone else can repeat it. We are theorists, so we mostly run simulations, so it's basically sitting in front of a computer all day long. And reproducibility means like I stick some input in, could be text files, binary data, I send it through some kind of program or script or whatever, and out comes a result. And that result should be the same every time you do it. And someone else should also be able to reproduce your stuff. So of course, for the input, I guess you're responsible yourself, but when it comes to the programs, right, you need to rebuild your programs in a reproducible manner that you have the same dependency chain with exactly the same versions all the time. Standard problem, I would say. So exactly same software is also on order you start looking into. And you can even ask yourself if you need the same hardware to be 100% reproducible in the end. But so obvious answer here is that Nix, of course, is perfect to solve the software part of this equation very easily. I would consider this almost standard now. So let's have a little bit of what's actually already available in Nix packages, and just going over like with find over the Nix packages source tree. Surprisingly, biology is very active here in packaging stuff for their domain. Chemistry, a little bit less, but we're working on that. Math, 170 packages, physics, astronomy. You see also some kind of activity here. And of course, what I didn't count is machine learning and data science, since those packages are spread over much more categories in mixed packages. So if you talk about then what kind of basic infrastructure in terms of packages does Nix packages provide us? From my perspective, something that you always need is some kind of MPI library. MPI stands for Message Passing Interface, if you've never heard of it. The parallelization suite, which is very common in the scientific community. BLAS, LARPAC for linear algebra routines. That's pretty much entangled anywhere. And if you look in the Nix store, you probably have
BLAS implementation even on your desktop almost. Same fast Fourier transforms, FFTW library. If you start overriding that, you cannot even reinstall Firefox without recompiling it. And of course, we have like the more modern stuff like GPU computing in terms of CUDA and so on, which is already nicely there. So then what we've created a few years ago is the so-called NixOS QChem overlay to bring in more quantum chemistry packages. Very specialized domain, of course. The name might be a bit misleading. Of course, it's not NixOS specific, but well, I started developing it solely on NixOS, and the name kind of stuck. So we use this as an incubator for new packages, and well, some packages maybe will have a forever home there. They will never get upstream to Nix packages, and they are so quirky that I'm actually embarrassed to open a PR for those. Well, what we also built into is like optimize for modern CPUs, so that we actually get out the best acceleration that you can potentially get out of a modern system, and yeah, and provide basically everything that someone who is a computational chemist actually needs to productively work. This is very closely coupled to Nix packages, of course, so it's not like we only take stuff from Nix packages. A lot of stuff is flowing back to Nix packages once those things have actually been worked out. So this approach with the overlay, we have published that even in a scientific journal, which is very nice because now we can actually go ahead and say, when we did a calculation, we can say we used this and this and this program, and basically NixOS QChem with that hash version, that's how we did it. And then everyone else can basically just take it and reproduce it. Yeah, so a little bit structure of the overlay. I think there might be some tricks, tips and tricks in there which are interesting in a more general sense. So what we did, we didn't do that initially, and it causes a lot of problem. Actually, all the packages that get introduced by the overlay, they do not just get in the default attribute set, but they actually get into a subset so that you have nice separation and you avoid name collisions. Just imagine you have a package called Mesa. What could possibly go wrong, right? In terms of name collisions. Nothing works anymore in your system. Then we have introduced some customization so that you can easily turn on those kind of CPU-related optimizations and so on to make that a bit more palatable. And what we also do is we take packages from upstream Nix packages and project them into the subset and then apply our optimizations for it. Also includes tests. Tests are actually super valuable, as you all know, but even here, helps a lot to detect problems early when you update stuff. So how does that look like? What we do is like Nix packages has this config parameter, and we basically just inject our config here in qchem-config as another subset. And you can then, for example, turn on simple tools like use CUDA, which turns on CUDA and all the packages that support it. Or we have a nice neat trick where you can supply a specific internal source URL, which then overrides your require file, so that you don't have to load all the proprietary packages manually into your Nix store. And then, for example, here the opt arc, where you can pick something that is already defined here in libsystems architectures. For example, for AMD CPUs, you say send 1, send 2, or something like that to get optimized build inputs. Plus some other convenience things that make it sometimes easier to handle, like injecting license files for proprietary software. So then, when we talk about customization, let's actually walk back a step and see what's already in Nix packages. So what we have in Nix packages is MPI, and MPI comes in 3 different flavors. This is OpenMPI, that's the default, most commonly used these days. But you also have something like MPI-CH and MV-APITch that you could, in principle, use as a implementation. Those MPI APIs are actually very well standardized, so they should be very well and easily replaceable. So what we did is like the standard, the default OpenMPI maps to MPI, which then means like if everyone that writes an expression that uses MPI, you just use the MPI attribute to consume that, and then you can simply write an overlay and replace it, for example, with another implementation. And that's then also sometimes useful because here you have different optimizations, maybe for InfiniBand networks or something like that. Also interesting because with a setup like that, you can very easily, for example, run a Hydra, which we do, and then build all the different variants and see how well that actually builds. Spoiler alert, not everything builds with everything in the end. That's, I think, the short message here. Then we can do the same for BLAS and LAPACK. That's also a feature of Nix packages already. And I think credits here go to Matthew Bauer, who put that system in. It's actually quite sophisticated how that gets replaced here. Those are your linear algebra routines, and in most packages, they're really like absolutely crucial to get good performance out of it. So again, you have different implementation like OpenBLAST, the open source default here. You have Intel's MKL, Bliss and Flame from AMD, and so on. And it can, in principle, replace that. Again, works then here super easily with an overlay where you just, for example, replace the provider here with MKL. We also built that in different variants on our internal Hydra, and it turns out that's actually a much more complicated problem, and a lot of things actually fail when you start replacing it. So it's an interesting case study, I would say. Then CPU optimizations. This is something that we actually have played around with in the overlay, and different ways of how you can potentially do that. And of course, the easiest way is to, in your standard env, to basically start replacing compiler flags to get optimizations. However, if you replace your standard env, you get an absolute mass rebuild, and if you just want to do that for your scientific software, it might actually be a bit too expensive if you want to really do that. So we opted for the intermediate version where we actually only rebuild the packages in the overlay with an overridden standard env. And then we can, for example, change host platform and add flags like AVX and so on to the standard env, and use also some GCC-related tuning options to speed things up a little. And this is actually a nice feature, again, already nicely laid out in Nix packages itself, that you have here the host platforms and all the flags that are potentially supported. For example, if you have a package that have a configure flag for, let's say here with AVX in that case, then we can simply add an optional and choose the default here nicely from standard env host platform, and you pick the flags that you want. Nice advantage of that is if you write it in that way, if you overwrite your standard env with the respective flags here to support the flags in your CPU architecture, your things get automatically built in an optimized way. And that has turned out in practice actually works quite well, causes little problems so far in practice, and makes things actually really much faster. So the last part of this part of the talk, just a little example how we use that in practice here. With a workload manager, again, you just send away a shell script and the workload manager takes care of it. So what we use heavily here is basically the shebang header feature of Nix shell. So that's actually then also on the wish list for the new command line interface that we would basically get a replacement for that feature. And then you can either use the sloppy version and just define, okay, you want a particular program here, or instead of using -p, you could also say, I point to a particular Nix shell file with pinned dependencies or so if you want to run it absolutely clean. So 4 years of experience and lessons learned from packaging stuff. Reproducible tests and results. A lot of numerical packages come with some form of test suite. Right? So then you would say, okay, if I give a specific expression with pinned dependencies to someone else, it should run exactly the same way, right? Yeah, no. We had problems where there was actually not the case. So there are certain impurities, for example, that especially OpenBLAS and MKL libraries do that. They have a feature called dynamic CPU detection. So they detect at runtime what platform they're running on and what optimizations they want to turn on. Nice feature, makes it super fast, very easy. But you know, sometimes you use different kind of optimization, and there's a bug in a library or something like that. You run it on a different machine, test fails on one machine, test runs on another machine. Absolute nightmare. So if you want to really get rid of that, you basically would have to turn off the default and compile OpenBlast, for example, for a specific CPU architecture. And hint, for everyone who didn't get the message, never ever use GCC's fast math optimization. That actually can lead to the fact that you don't even get reproducible results with the same program on the same machine on the same day. Only use that if we really don't care about precision or anything like that. So test fruits and resource usage. You know, a lot of programs are run with, they are compiled with OpenMP, which gives you nice, easy thread parallelization. But what does OpenMP do when you don't tell it how many threads to use? Well, it just uses all of your cores, right? So now you have a build machine with 64 cores. They're all blown up. Disadvantage is actually that the test cases are usually very small, and they are sometimes actually much faster if you just run them on 2 threads than on 64. So this can cause massive slowdowns, and I think I have actually seen that in the wild, for example, with a package like NumPy. To get rid of that, simply set OMP num threads variable to a small number in your install check phase or wherever it applies to get around that problem. Same thing a little bit for MPI. There's even a bit more difficult since there's no real auto detection here. Whenever you have something that actually runs, run it with a fixed number of CPUs. Makes your test much more reliable, build faster, and yeah, in general, more reliable. So another interesting thing that we observed are Fortran-specific features. And I don't know, this not everyone might be familiar with that quirk of Fortran, but Fortran has a default integer size which is not clearly defined on a 64-bit platform. So it's simply defined by a compiler switch. You tell it, I want my default integer size to be 4 byte or 8 byte. The problem is that your compiler has no means of actually detecting what a dependency was compiled with, which leads to the fact that you can have a mismatch between your app and your library. It compiles just fine, and then simply crashes at runtime. So also a very important message, especially in those cases with BLAS and LAPACK. Test things, run tests, see if your binary actually runs and halfway does what it's supposed to do. With this kind of nice setup in Nix packages for BLAS and LAPACK, we have this like is ILP 64 flag now basically in the wrappers in there, which is a super nice feature because then you can simply add some asserts in your expressions and make sure it's actually set to what you want it to set. That it's actually that the dependencies have the right integer size. The fact that you know, some scientific software packages they're old. They maybe have their root in the 80s. Scientists are not computer scientists usually, but physicists or chemists. So things can end up a little bit quirky, and then not always built in the most standard way. So a lot of things comes from broken CMake. CMake not used in a way it was supposed to be used. Total nightmare interactive installers, which basically ask you in which path is your library, which compiler flags do you need to get the library built, and so on and so forth. The next thing we had was very well intended probably by the developers. You have a program that comes with a shell script. It builds, installs itself automatically into a home directory and inserts or of course, pinning dependencies the non-Nix way. You start downloading things or checking out Git repositories during build time. Doesn't play well with the Nix sandbox, of course. I think Wild West of build systems, the only advice here from that is like be creative, patching that kind of stuff out of your build systems. There's probably no other way if you actually need those quirky packages to work. Nix packages pinning. I mean, of course, we support flakes, but we think we even went a little bit further and said we always pin our overlay to a certain Nix packages version because otherwise things break way, way, way too easily. And we have a little bit of a hack here that we actually make use of flake lock, even if you're not using flakes. Might be a dirty hack, but works quite well in practice actually to keep things stable. At least as long as the format of flake lock doesn't change. Yeah, okay, that's already at the end here. Like summaries, I have to say, last 4 years has served me well. We use it in production in Stockholm and in Jena. We have our own small cluster running with it, productive use every day. Updates are actually pretty much always easy. You can keep old versions. Things are super smooth. Little breakage, little headaches. Yeah. Now we actually have really, from a scientific perspective, we can share certain environments very easily by pinning simply to some Git hashes and sharing that one somewhere else, which makes it super citable also, which is important for us. Some things may be difficult to package, but not impossible. I think there are only a few things that we actually gave up on. And I think for our community, this is almost a complete toolkit by now. And yeah, of course, contributions even to the overlay, they're always welcome. So outlook, what's important in the future, what we didn't have addressed so far, benchmarking. Benchmarking is how long did a test run on Hydra? Much more complex than that. So there needs a lot to be done there. Then what's not integrated whatsoever are vendor-based compilers like the Intel compiler, AMD compilers. A lot of people depend on that. And of course, the outreach part here again, if you want to use it on supercomputing centers where you don't have root access, you have to kind of convince administrators there to install Nix for you. Yeah, and that, I'm at the end. Thank you for your attention.
So we have time for 2 questions, and I already see hands. Oh, wow. Yeah, I'm going to go to the one I saw first.
Hi, so are you able to build your packages with any other compiler than GCC?
Yeah, in principle, it should be easy to overwrite your compiler, like for example with LLVM or something like that, right? But I haven't tried that. So we have experimented with different versions of the libraries, but not with different compiler versions.
Okay, thank you. So I really appreciate you bringing this topic in. I can barely contain my excitement. So the short version of my question is we should talk afterwards. But for the benefit of the audience, first a comment, if you have user namespaces enabled and like shared storage or something, then you don't need root access to have Nix because you can just use it like that. I don't know if that works for you.
That is true. I haven't tried that. Since if you have everything running on NixOS, you're so comfortable that you don't even want to go somewhere else anymore. But it depends on, I guess, what the setup on a computing system is, because some setups are actually like very conservative with very old kernel versions.
So maybe that's worth something looking into. And my actual question is, a medium-sized legacy university cluster at some point. And the team members don't know Nix, I know Nix, and we aren't looking to use Nix on the system because, of course, users need familiarity, the administrators need familiarity, but I'm constantly keeping it in mind to see if I can maybe push this into the system at some point, maybe in parallel with the usual tooling. And the question is, are you familiar with, have you looked into like existing tooling for HPC systems like Singularity, SPAC, the American HPC clusters seem to have a lot of infrastructure that looks pretty good for packaging things that of course isn't Nix. But like the important part here is you really need user buy-in. So we're going to be doing this mainly for medical and genetics applications. Like, do you have any insight on this?
Well, I haven't, SPEC I haven't used personally myself, so I have no experience with that. The Singularity containers you can use, they did with several nodes or something like that. Things actually need a lot of hacking to get it even working at all. So Singularity, as hyped as it is sometimes, I wouldn't recommend it on a larger scale.
Okay, thank you.
So the next part is going to be interesting.
You can
because no, not this. Why is it going to be interesting? Because we're going to switch roles. So far, the live audience over there has been seeing a mediocre stream. But now we're going to stream into here. And then hopefully there's going to be a live going a little bit hacky. It looks like a hackerspace at the moment at the control desk, so that's why. So thank you for bearing with us.
Hi, everyone. Thank you for attending my talk. Sorry I couldn't be there with you in Paris. Maybe next year. I'm very fortunate to have you let me give this talk remotely, and I should be online to answer any Q&A at the end of the session live. So the topic of my talk is rethinking basic primitives for store-based systems. And this is some work put together by myself, Tom Skoglund, and Carlos Maltzen. And we're out of University of California, Santa Cruz, and Lawrence Livermore National Laboratory. So this talk's kind of a story, or maybe even a call to arms. By the end of this talk, I hope to have sold you on a few things, and most importantly, that perhaps we as a community have not taken full advantage of the Pandora's box opened by ILCO. Actually, that analogy isn't that great, since Pandora's box, I believe, let out despair and pain in the world. Well, maybe that's a little bit what it's like to learn Nix, but all joking aside, what I meant to say is that Nix and similar store-based systems have ushered in this new paradigm. And they've unleashed a lot more opportunities than we've actually taken advantage of. I've included some fun dolly art here with the also prompt I gave. So yeah. I thought I'd start off with maybe a quick depiction and where were we prior to the invention of Nix? You know, maybe to many of you this won't be new since this is obviously a Nix convention, but I wanted to set the stage for those that are still coming and that are new to Nix and maybe might watch this online. Well, up until Nix, the world has largely adopted shared libraries to solve a variety of problems. Shared libraries are great in that there is a single library on the system with which all others link against. That makes it incredibly simple and easy to upgrade libraries in the face of security vulnerabilities. In a world when bandwidth and storage are at a premium, coalescing onto a single file and shared library at a particular version was efficient. Of course, and perhaps this will ring true to many of you, and why Nix itself is so effective, sharing these libraries was incredibly risk-prone and a compatibility nightmare. You know, Nix, as I described to many of my colleagues and friends, you know, fundamentally solves the it works on my computer or it doesn't work on my computer, but it works on yours. This problem has only really gotten worse with time as the software we've built has become increasingly more complex and dependent on others. So shared libraries. They're the cause of and solution to all of life's, well, our life's problems. This garbled mess here is the build and runtime dependency for the C Ruby interpreter. If you're really struggling to make sense of the graph, great. That's my intent and by design. Really, the purpose of the slide is I only hope to communicate that our software has gotten increasingly complex and the use of shared libraries and dependent code in general has exploded. So the problems in the previous slide have only gotten worse and are exacerbated by the widespread use of shared libraries. Of course, the rest of the world has dealt with this explosion through established conventions, specifically the file system hierarchy standard. These are the directories you've either come to love or hate. Maybe you have them tattooed on your arm. Libraries are found in /lib or lib64, executables in /bin, and configuration files in /etc. This convention underpins most Linux distributions and is maybe at the core of what Nix is attempting to resolve. If you read the Nix PhD thesis, which I recommend you do, the main contribution to me is that we should treat our file system more like well-structured objects and less like a global mutable file system. But there is something to be said. This convention has gotten us pretty far. It's well established, well understood, and simple. So hopefully most of us are familiar with this slide as we're at NixCon. But basically, it's an extremely short summary of what Nix is. And it's an alternative to the world of that convention I spoke to previously. Rather than everything being placed within the system implicitly, everything must be placed within a well-known root, the Nix store, in the graphic depicted in the graphic on the left. And dependencies can only exist within other entries in this store in a very explicit manner, also depicted by the arrows. In the case of shared objects, Nix utilizes a feature of the executable and linkable format, aka ELF, to specify a configuration parameter known as runPath, which dictates where the dynamic linker is allowed to search for dependencies. RunPath, like most things in Linux, is a single list to begin a search, very similar to path or LD library path. I've included an example on the right of Ruby. This is continuing on the example of using Ruby from the previous slide. And I've printed out its RunPath. You could imagine in the graphic on the left as well, Subversion here uses OpenSSL and glibc. Those two entries of the directories would be on the RunPath, which is colon delimited. Okay, so problem solved. Perhaps at this point, we're all thinking, great. Although Nix solves a lot of the initial challenges faced by models, such as the file system hierarchy standard, it effectively still relies on many of the fundamental concepts introduced by that world, and at times appears to only band-aid over them. Lots of aspects of that are great. It's pragmatic. They're honestly what helped make NixOS and Nix into a usable system right away by using primitives that already existed. But as our ecosystem begins to mature, we should be asking ourselves more fundamental questions about these underlying systems we leverage, and whether there are opportunities to reshape them in the new store model that Nix has ushered and introduced. I'm going to spend the next couple of slides walking through some issues that are present in the underpinnings of what Nix builds upon, and some ideas of how they could be repaired. Shared issue number one. Shared objects are only loaded into memory a single time during traversal, usually based on their soname. If a shared object has already been visited and is needed by another dependency, it'll be provided without a lookup. Great, that's an optimization. And it'll not raise a warning or error, however, if that library would not actually have been found. We found several cases through discovery and anecdotal data through our own work and experience where this happens in practice. The image I've put above here is one such example of a tool called dbwrap. You can see that libsamba debug samba 4 was, and that's where the arrow is pointing to, near the bottom, is a shared object that was loaded earlier. And the loader goes in breadth first order or level order. So it loads that first. So however, when it came to try to load it again, and that's the highlighted blue, it actually should complain that it cannot be found. And that's because its parent was missing the RunPath entry to locate it. The tool, however, runs fine because of that optimization of skipping trying to reload shared libraries we've already loaded. This issue is trying to expose the idea that although Nix aims to be incredibly reproducible and document all edges of our graph, it's possible to actually get to running software while still missing these edges. Here's somewhat of a paradoxical example of an application that may want to link against two libraries, library A and library B, or lib A and lib B, found in directory A and directory B. which I've highlighted them in green in this graphic of the desired libraries to load. Unfortunately, given the coarse nature of run path, and this problem applies to also LD library path as well, there's no way to do this in the current model. The only two ordering options that exist for these directories I've put on the slide. It's either directory A : directory B, or directory B : directory A. And neither of these orderings will result in the desired outcome. If directory A is in the front, then library A and library B will both be loaded from directory A, and vice versa if directory B is at the front. You know, at best, a new directory structure must be created that symlinks to the correct library, but that adds unwanted complexity to our software setup. In this issue, Nix is still relying on primitives that predate to control the system, and those parameters do not offer enough granularity and control for what really Nix or any highly fine-grained system requires. Another issue which has also been written about by the developers at Geeks are the needy executable binaries. Binaries have gotten a lot more complex, as I've discussed earlier, and the number of dependencies they rely on have gotten increasingly large. Here's a notable example, which many of us are familiar with. This editor, or maybe referred to as an operating system Emacs, has 100 dependencies found in 36 directories that comprise the run path. This provides a worst-case scenario where if all dependencies are found in the last directory, causes a lot of unnecessary file system calls. You know, hypothetically 3,600, as I've written on the slide. You know, in practice, it's actually a bit less, however, still significantly high, 1,800 file system calls, which can be pretty disastrous if these paths are on a networked file system, for instance, and they have negative caching disabled. You know, this is overall not a new problem, and traditional Unix systems employ something known as the LDSO cache, which stores the location of a library to its path on disk. Again, this was, however, designed as a system-wide cache and breaks down in a system such as Nix, where multiple variations of a library can exist. So that's about the issues present. Now I'm going to propose some solutions, some which we've implemented already, and some more as a call to arms or ideas I'm exploring. So the first idea is we've called shrink wrap, and it's the idea of flattening the graph and pointing all libraries to their absolute path. Again, the tool hoists all needed entries of the final binary to the top level. So I've shown a graphic here of the Ruby application, and it has a typical directed acyclic graph. And after the transformation, all the dependencies are duplicated at that first level and are now pointed to by their absolute path. Because of the caching and duplication in glibc, it means that all libraries are effectively loaded from deterministic locations and in a deterministic order at startup. We no longer have to rely on runpath or rpath for loading sub-libraries, except for dlopen. This is great. Loading of needed entries is now deterministic and well-known, and we can avoid that costly lookup that I spoke to about earlier. I'll actually be presenting a paper on this at this year's supercomputing in Dallas, Texas. If you're interested in the paper, please reach out and I can give you an advanced copy. Interestingly, Geeks chose a completely different approach to achieve something comparable, and they patched the dynamic loader to make that LDSO cache per process rather than system-wide. I think there's a lot of simplicity here, however, in seeing all your dependencies up at the first level. and avoiding any need of a cache. Here are some results of the experiment. I chose Emacs because the Geeks developers posted a blog post and used that as their experiment binary as well. The number of library dependencies needed by Emacs the number of library dependencies needed by a particular binary and the number of entries in the run path can vary greatly. However, in the case of Emacs, we see the ideal drop after shrink wrap has been applied. So about that 1,800 file system calls to open and stat down to 104. And the time reduction, and this was just done on my laptop, so it's in microseconds. However, we see a 36x improvement. Again, even though that was in microseconds, these times can be inflated on an NFS machine with cold cache. And these are time spent on every process startup, on every machine that's running Emacs in the Nix model. The bottom graph is of the Pynamic benchmark. It's a dynamic loading benchmark built basically exactly to measure this startup cost of loading many shared libraries. The experiment was performed on the machine where the shared libraries were in fact on an NFS server with a cold cache and negative caching disabled. At the smallest size of 502 processors on 4 nodes, the normal executable took about 169 seconds to launch, while the wrapped executable, or the one applied with shrink wrap, took 30 seconds. And that's a speed of about 5.5. At 2,048 processes, the gap widens to an improvement of 7.2 for a total time to launch of 344 seconds for the normal executable. So these are real savings and performance improvements. The idea, which originally came from Harman Stoppels, is that so-name of a shared library is that you set the so-name of a shared library to its absolute path. I've called this idea Nix hard and needed, and it's basically bubbling up the world explicitly. Again, so you set the so-name of the library to its explicit path. It's Nix store. And anytime you link to this library, the needed entry becomes the so-name. So you're automatically propagating the absolute path. And we've just bubbled up complete removal for not needing run path anymore. Since in Nix, it's always safe to link against the full Nix store path entry, this removes, again, the run path or R path entries completely automatically. Things just build correctly. It's incredibly simple, pure and elegant. Here are some, now that we're getting into the ideas I am thinking about and don't, more call to arms, and I'd love to collaborate. So ELF has basically dominated the Linux executable format, especially since the deprecation of A.out, or the assembler output format. ELF itself has many of its concepts underpinned by those same conventions that dominated the FHS, or file system hierarchy standard. For instance, it encodes all the relevant information within a single file. Of course, this is desirable when our goal previously was to update only a single shared library file, and we wanted to guarantee some levels of atomicity. However, since Nix solves the multi-file atomic update problem, why should we accept that? Why should we accept that all data needs to be encoded in a single file? Understanding and working through this data is incredibly challenging. One only has to look at PatchElf, which was written by Nix for Nix, and which we rely on heavily, and the bugs against it to see the problem. I don't really know of what another layout could be. I give an example here where I basically just explode ELF into individual files, but maybe files isn't even a good abstraction. What happens if some of this information existed in a database, a SQLite database? Again, the fundamental idea here is Nix allows us to use a different loader. And it allows us to think much more deeply about these fundamental primitives and to eschew them. Finally, Nix needs its own dynamic linker. If we were to avoid using ELF, the experiment was performed on the machine where the shared libraries were in fact on an NFS server with a cold cache and negative caching disabled. So name. So you're already since the deprecation of A.out or the assembler output format. ELF itself has many of its concepts underpinned by those same conventions that dominated the FHS or file system hierarchy standard. For instance, it encodes all the relevant information within a single file. Of course, this is desirable when our goal previously was to update only a single shared library file, and we wanted to guarantee some levels of atomicity. However, since Nix solves the multi-file atomic update problem, why should we accept that? Why should we accept that all data needs to be encoded in a single file? Understanding and working through this data is incredibly challenging. One only has to look at PatchElf, which was written by Nix for Nix, and which we rely on heavily, and the bugs against it to see the problem. Finally, Nix needs its own dynamic linker. If we were to avoid using ELF, we basically need our own dynamic linker. Doing so opens, and maybe even our own executable format. Doing so opens a wide range of opportunities, areas of research, optimizations, and we won't be so constrained by the conventions that were placed before Nix was created. Writing a dynamic linker is no small feat, but Nix is primed to do this. Not only does it have an operating system distribution so we can make deeper changes if we need to, but the opportunity clearly it went very abstract. Yeah. Thank you, and that's my talk, and hopefully I see you live for some Q&A. Thanks.
So we're going to try this, right? I have no sound yet. Yeah, okay. Can you unmute me real quick? Okay. I'm sorry, Farid, but I'm going to mute you for just a second. There we go. So Farid is no longer audible. The thing is, we're going to try do a Q&A. I hope Farid can hear us as well. We're going through multiple layers of IP currently, so there's some delay in there. Yeah. It's a new experience here. Okay, sure. So is there a question currently? Yes, I'll go to the very back. So just speak your question and then we'll unmute and then hopefully it'll come through eventually.
Hey, so that was fascinating. Thank you. You're proposing a new dynamic loader, which is like a really exciting and intriguing idea. But how would that work if Nix is installed in a single user fashion? Because you wouldn't be able to like put that in a well-known location, right? So do you have any like idea on how that could be possible? Or would that be a split between the Nixos world where we do have this loader installed somewhere and the like rest of the Nix world where that might not be the case? Thanks. Loader installed somewhere and the like rest of the Nix world would.
Can you guys hear me? Test, test. Yeah? Oh, okay. I'm sure there's some lag. Thanks for letting me do this remote. It's also in the morning, so if I say something wrong, it's because I haven't had any coffee yet. So the idea, I think, could work in both the Linux distribution of Nix as well as NixOS. The dynamic linker is set in the interpreter path, so it doesn't need to be in a well-known location. So the dynamic linker could be specified as part of the base installation of Nix. I think the last slide also mentions not only is there the opportunity to write a dynamic linker, but even perhaps pursue our own executable format. I think there's a variety of ways to do that. Most likely would need NixOS because you could write a kernel module to support a new format. I'm still thinking through whether you need a new format or you can kind of like at runtime patch up ELF from this expanded way with our own custom dynamic linker. I mean, the challenge there is it's a lot more complexity doing it, faking ELF. The real premise of the talk is I think that's okay at the start. Nix has always been great at pragmatic decisions to start, and that would be one. Just do a dynamic linker first. Don't do a new executable format. But longer term, the talk is saying Nix can be more pervasive and more deeper and challenge all these status quos that I think, whether we take for granted or we just see and we assume can't change. And Nix is really letting us change everything from the ground up.
Thank you for it.
Can you repeat your question, please?
Okay, from the beginning. Yeah, thank you for doing this. I'm glad to see that the issues, there's a gleam of light on the horizon for the issue that I opened 5 years ago. Do you think it would make sense to extend the existing ELF format rather than to come up with a new one, given that, I mean, it's happened in the past. We now have run path and R path when we used to have only R path, which behaves strangely. So I think that other people can benefit more from it if we extend the existing standard. Can benefit more.
Someone give me a thumb up. Can you guys hear me? I need to know when to speak. Test, test. Okay. I might say some foot and mouth answer here. My gut is no. ELF is already extremely configurable. It has no. It's like the FHS. It's all convention. It's really just a section of containers, and by design, things have come up in tags that mean specific things. Adding more to that convention seems to go against the problem. My approach is we can have very targeted tooling that works extremely well for Nix rather than putting a diaspora of things that work well together. Why do we want to use tooling that has support for RunPath and RPath? And I don't know if you know this, but like RPath only works at the top level of the graph. RunPath works like parent change through your ancestry. I mean, it's just mind-boggling to try to keep track of all these different things when we could just do something super simple, because in Nix, you know the full graph. You know everything you're going to link to. Like a lot of these problems can be solved. So I guess my answer would be no. Yeah, but I mean, yeah, at least to start, and then it's just such an uphill battle, I'm sure, to extend ELF, and I don't know what kind of consortium you need to do that.
Okay, thank you, Farid. Farid, we can no longer hear you. I'm terribly sorry, but we have to move on. So if I can get one more round of applause for, first of all, the hacky setup and for Farid as well. Okay, we're going to have a 5-minute break. We're going to reconfigure the mess over there again. So within 5 minutes, we're going to continue again. Thank you. Why am I so quiet? Hello. So, we're back into full physical form. There is no longer things happening. There's no longer people online trying to hijack this conference. Can I be a bit louder, please? Can I be heard? Maybe we can sing.
Maybe, yeah, what's on? Something French?
Yeah, sure. Can I have everybody's attention, please? We're about to start again.
Slowly. Getting there.
Slowly but surely.
Hey, everyone.
You can put it a bit higher. Okay, for those that are still talking, you're going to miss out on a great talk, but I'm sorry, I'm not going to delay this any longer. So, Domin, thank you for wanting to talk. I wish you the best of luck for your talk. I don't think Domin needs an introduction. Most of you know him by now. Good luck.
Thank you. Woo! Thanks, everyone. It's so great to be back to NixCon. It's been a while. So, all right. Yeah, I wanted to talk about a bit what we've been working on at CashX for the last kind of year. And I'll start with a slide that I think I had for the last few NixCons, which is the two kind of areas of focus. What's the feedback loop? Okay. So it's documentation and infrastructure. Am I talking too loud or what? Oh, it's not me. Okay, good to know. Yeah, all right. So in the last few years, I started Nix.dev, which I think Valentin will talk more about where it's going. But the original idea was to kind of go away from what community is doing and try to write actual documentation and see, how to get there, and then slowly start to drive this project back into the community. And this is kind of like what's happening right now. And on the infrastructure side, probably most of you have heard of or are using CashX for binary caches, and now we have already CashX deploy, which is in kind of beta phase. Oh, by the way, I totally forgot. Who is doing Nix, who is writing Nix as part of their full-time job? Can you raise your hands, please, just to see? Nice. Woo! So just for reference, I think last NixCon, it was just a handful of hands. So, there's definitely progress. Yeah, so this is kind of like the areas of focus right now. So why did we build another deployment tool? Obviously, because there's not enough. There's probably more than just these, but there's a lot of projects out there that are trying to, and even NixOS itself comes with kind of like a deployment tool, NixOS Rebuild. So I would like these tools and what kind of purpose they serve. So the main focus was to kind of think about what would be the minimal tool that is the easiest to use, the simplest to use, and kind of fits a lot of the use cases out there. So talking about developer experience, in my mind, this is intuitive interface, kind of supporting known workflows and really good documentation. Actually, one of the reasons why I started this project is because I wanted to have a reason to write documentation how to deploy Nix, and the best way is to write a tool, and so here we are. And the last one is the simple setup, which is, I don't know how many of you are deploying NixOS, but like if you, let's say, deploy to Hetzner nowadays, everybody has their own scripts and their own ways, and it's kind of like, people are copying from each other and so on, but there's no, at least I don't know any really good tutorials, for example, how to deploy NixOS to Hetzner, and I'm talking Metal because that's a bit harder part. So and the other reason is that I've always managed my laptop like this, by editing configuration.nix and switching as a root. And then you want to have that in a Git repo, so you have Git repo in root. And I always forget to push and commit because it doesn't matter. I don't know if you're familiar with this problem, but this is something that I've been always kind of unhappy about. And kind of like my dream workflow would be that you edit like any other software project nowadays does do the job. And I think that's a better workflow in my opinion for this kind of stuff. So to go through some of the design decisions behind it, and I'll show you a bit more about how it works. A lot of the deployment tools out there are using kind of like the push architecture, that you push things to the servers. Cachix deploy uses pull architecture. There are a couple of reasons for that. I think Nix is closer to the pull architecture than to push, mainly because if you pull things from binary cache and everything is already there, then it's much easier to scale. Let's say you launch 1,000 of machines and so on. And it's a bit, I'll talk a bit more about like other bits, but the binary deployments are just because I think that there's no reason to evaluate, to build or anything on the target machine. This could be just because, okay, you might have an IoT device that easy, and we have CIs and so on that kind of take care of this part. So they should be, I think, responsible for the building and evaluation. So on the target machine or server, whatever you want to call it, it's just downloading binaries. So it's just streaming data to disk and then activating whatever Nix wants to do. And it's kind of like tailored towards CI/CD workflow, as I said, which, so who is using continuous delivery in their projects, as in that, continuous, can you raise your hands? All right, there's quite a few people. Yeah, so the idea is that anything you build goes directly to the servers. That could be staging or production, depending on the workflow. But there's absolutely zero effort for that to happen. And one of the design decisions is that it's cloud scale. So if somebody wants to launch, let's say 1,000 or 10,000 servers with Nix, that should just work out of the box, and there shouldn't be any bottlenecks. Again, choose it for my laptop, and when you travel around, if something pushes to your laptop, yeah, you have a problem there. There's other tools like Tailscale and so on nowadays to solve this problem, but this design decision makes it that you don't have to use any of these tools. And slow, intermittent, connection friendly. So like when I edit my laptop, for example, and I'm traveling, which I often do, I don't need to like download a lot of things and push them back to binary cache while I'm somewhere on a slow connection. So not always you will encounter this kind of thing, but it's kind of nice that CI can handle that and do it in the fastest way. And another thing that deserves its own slide, I think, is provisioning. So for example, NixOps that we use today kind of handles provisioning, and there are different tools to provision servers or infrastructure. But in my opinion, like Terraform is really good tool that is maintained by a lot of people at HashiCorp. And at the moment, I don't think that, we have the capacity to kind of be better. We can, I think, but right now we are not. So a lot of people will use Terraform, and so Cachix deploy does not solve provisioning. That is kind of like just about this. So continuous delivery. Are you ready for complexity of this? So the idea is the CI builds the Nix derivations, pushes the binary cache, and then all the agents kind of just pull things from the binary cache and activate. So very simple. So all right, to show you how it works, Cachix deploy agent, and then you specify the name of the agent and optionally the Nix profile name. So this could be system in case of NixOS or something else. By default, the agent will kind of try to determine the profile on its own. So if you're running the agent on a NixOS machine, it will figure out that you're deploying to NixOS machine. If you're deploying to, let's say, macOS, it will assume you're using Nix Darwin, and it will just auto-install Nix Darwin on the first deploy. So essentially, you don't need to do anything to, let's say, bootstrap a machine. And I'll talk about how the deployments come to the agent. So the agent will then just connect to the service and await deployments to come in. And in the next release of Cachix, there's going to be also a bootstrap flag, which is kind of useful. And I'll talk about this a bit later when you want to like just start the agent to perform the first deployment, and then that agent kind of just stops, and the deployed agent takes care of takes over. So for example, if you wanted to let's say manage a Nix Darwin profile, you would use this to do the first one, and then Nix Darwin would start by the configuration with their support for Cachix deploy, and its own agent, and this one would exit, and that one would take over. So essentially with this, you can just very easily start and managing your NixOS, Nix Darwin, whatever, Nix profile with one command. I'm leaving out the tokens here. You need to specify token, but that's boring stuff. And yeah, Nix Darwin derivation just works. So this was the agent part. So what the agent does, as I said, it connects to the service and it's kind of awaiting what to deploy. So on the other side, Cachix deploy activate, and then you give it a path to a JSON file, will actually activate a deployment, and you can specify, as you can see there, agents. So deployments are essentially mapping between agents and store paths. And then the agent kind of determines what's in that store path as it downloads it. And there's also support that if something goes wrong and the agent does not connect back, it will automatically roll back that deployment. So it's kind of like a sanity check. But you can specify your all rollback scripts. And if this script exits with non-zero, then it will roll back whatever is deployed. So you can kind of like do sanity checks and things like that. So this part kind of is declarative interface to deploying, and is usually should be done, I think, from the CI. And I'll show you a bit later. Okay, all right, I have 12 minutes more. So, right, documentation. There's documentation how to deploy just a normal Nix profile, NixOS, and Darwin. I would like to add how manager support as well. And just after NixCon, I will release the tutorial for Amazon AWS, where kind of like we pre-generate the AMIs that already have Cachix agent there and everything. So you just apply the token and a name, and then it will just connect. And then from your GitHub repo, you can just start pushing your new derivations to the agent. So there is no need to generate an AMI and anything. And these deployments are really fast. When the agent gets a command to start a deployment, It will download all the binaries and activate, which is extremely fast on most machines, especially on Amazon, and usually takes a couple of seconds, depending on how much you need to download. And the next release is gonna also optimize that to be even faster, so it's really quick. And then there's gonna be a tutorial, which is also in the works and almost finished. Sander is working on this, that is going to create a Terraform module that you can just point to any server that is running Nix, that has Nix installed, and it will just like start and bootstrap the agent. Usually NixOS or NixDarwin and so on. And as I said, there's most of the focus in the next weeks is going to go into tutorials. So if you have specific targets where you would like to deploy these, please let me know, and I'll do my best to cover that. All right, so one of the next things that is coming up, we've kind of partnered with Sirocco guys, and they're gonna help with, I don't know if you know about NixDiff. Gabriela Gonzalez wrote this really nice tool that you give it 2 derivations, and it will kind of show you the difference between them. So what I would like what Sirocco guys are gonna be doing is, this tool right now just outputs stuff to the terminal, but it would be really nice to have a JSON or some structure that then can be machine read and displayed. So they're going to work on that, and in general, just rethink how do we see the difference between 2 deployed Nix derivations and try to display that so that, there's been previously talks about, how to inspect the closure size and all of this, and I think it would be really nice to have good interfaces to this so that, in a couple of clicks or in a couple of, let's say, minutes, it's clear, what's going on. Why did the closure size increase, or even that they're planning to explore. All right, and the last bit is, as you know, as we mentioned before, we are organizing a sprint, which is kind of like a hackathon where around 20 people come to where I live and where Nate lives on Lanzarote. And we already did 2 iterations so far. So we have the 3rd one coming in November. I think that the spots are mostly filled, but if you really want to hack on something to improve Nix, then let us know and we'll try to make some space. I think this is a great way to get things done that are usually not able to get done and just take 1 week. It's kind of from days and on the road, which has about 25 degrees every day. And we have catering organized so that you don't have to focus on getting the food, and you can just work together. And here are some pictures from previous events. So I would like to invite you, if you want to join, or you have some ideas, to join us. And most importantly, we are still looking for sponsors to cover the event. I hope that the NixOS Foundation will cover this kind of events, and more people will organize them in the future. But for now, we need more sponsors. So in case you're hiring, let us know. And we don't have a gold sponsor yet. But even if there's a sponsors plans on oceansprint.org. But if you cover as a silver sponsor, that really helps as well. And of the all right, so that's more or less it. I would just like to say that Cachix client itself is, of course, open source, and most of the stuff is going on there. There's going to be more development in the future. And the server side is closed source, and the first 10 agents that you run are for free. And currently it's in beta mode, so if you want to help out, that would be great. And I hope that within a month we will release the general availability of Cachix deploy. And that's it. I hope you have some questions, and thank you.
I didn't even get the chance to ask and already saw hands. So I normally deploy with Nixos rebuild, and I like the synchronous nature that I see immediately if I have like a syntax error or something, some silly thing that prevents it from building, and also then immediately after it deploys, I can also give it like a little poke to see if it kind of seems to be doing the right thing. So how does that work in the Cachix deploy model where it kind of happens asynchronously?
Yeah, that's a good question. So just to go back, so right now, so there's two parts to this. So right now, if you run this command, it will just give you a link to the web interface where you can see the logs. But in the next release, you will just see the output of each agent and what it's doing. So usually, if you would run this on a CI, you would get an email that the build failed. So this command currently does not exit with non-zero, but in the future it will, and you will see that something failed. And then from then on, you could, if it's something simple, you could, of course, you can evaluate and build locally while you're doing this. You know, but and run this command from your local machine if you need to kind of go into the interactive mode. My experience is, at least with NixOS, that most of the time, like evaluation fails and the build fails, and then the activation kind of mostly works right. So yeah, those are the feedback loops that you have available.
There are more questions? Yes. On my way.
This spec.json file, is this manually written or generated? I see store paths there.
Yeah, so there's actually a flake in the documentation that kind of provides functions to generate this JSON. So there's like a flake.spec, which will generate the top level thing, and then there's like flake.nixOS, which will kind of initiate a NixOS machine, or flake.darwin, which will create a Darwin machine. So there is like a much higher Nix interface that is exported there.
We do have time for one more. You kind of wrote them at the same time, so I'm going to go shortest first. I'm sorry.
I was just wondering how much overlap there is between the stats that Hydra is already tracking and the stats that you would want to maybe compare diff between generations of deployments here.
So you mean like the diffing between two deployments, or?
Yeah, like my understanding is Hydra already does some tracking of like closure sizes, and I was just curious if you could reuse that information or levy the infrastructure that Hydra has for generating and tracking that information here as well.
Right. So yeah, Hydra tracks, I think, closure size and build times, right? As far as I know. Yeah, we want to go much deeper into that. We want to show kind of like that what is the difference between two deployments, like you can kind of like dive into it. That's one bit. The other one is Hydra. I don't consider it as a deployment tool, although of course you can go, let's say, build a top level Nix closure, and then you can look at that. But you kind of like, I guess the interface will be different. That's my best take. All right, thank you.
Thank you, Norman. So up next, the legend himself, Ilko Dolstra, talking about a subject. I recently got flamed for saying the word too much in a meeting, so I'm not going to say it anymore.
Testing. All right. Let's get started with the last talk. I hope you still have some energy. Wow. There you have it. All right, so this talk is about, well, it's called Scaling Up Flakes, and it's about fixing one of the issues that is preventing flakes from being stabilized, namely a problem that a lot of people run into when they try to flakeify their project. So if you have some big repositories, then it turns out that flakes don't work very well. Because, as it turns out, Nix has this tendency of copying entire repositories to the Nix store every time. And what a surprise, that doesn't scale. So this talk is about fixing that. And that, takes away one of the big blockers for stabilizing flakes. So just a reminder of what flakes are for people who have never seen them. So a flake is basically just a source tree, like a Git repository, that has a file named flake.nix in it. And this is a standard way of packaging projects that have Nix expressions in them. So where you previously might have a default.nix or a shell.nix, flake.nix standardizes that. It gives a way for these flakes to have dependencies on other flakes. So you don't need to have this sort of mono repo anymore. And it's, in addition to dependencies on other flakes, flakes of course have so-called outputs, which are arbitrary Nix values like packages or developer environments or Hydra jobs or whatever you want to export. The flake format doesn't really care about that. And like I said, source trees can be Git repositories, but also tarballs or paths in the local file system. But usually they're Git repositories. So this talk is actually not really about flakes. It's about fetch tree, which is sort of the operation that underlies flakes. Fetch tree fetches a so-called input, which could be a Git repository or a path. So what's the problem? So the problem is large source trees, because Nix currently copies every flake or every tree to the Nix store. So regardless of what you do with the flake, it ends up being copied to the Nix store. So if you do something like Nix flake metadata on an arbitrary flake, as you see over here, that ends up in the Nix store. So if that is a multi-gigabyte Git repository, then every time you run Nix, it will first copy all those gigabytes of data to the Nix store. If you make one character edit to your repository, well, then you end up with a new multi-gigabyte copy in the Nix store. So this is not very scalable. And this is not just your top level flake, it's also all the dependencies like Nix packages. So you end up with a lot of copies of Nix packages in your Nix store. And disk space may be cheap, but it's not that cheap. So in particular, this makes hacking on large flakes very slow. So Nix packages is not even that huge of a repository, but it's already big enough that hacking in sort of on Nix packages in the flake way, using the new CLI, so you have saying nix build .#hello, takes several seconds because it needs to copy the entire Nix packages flake to the Nix store. And yeah, like I said, it costs a lot of disk space. So for example, here 93 megabytes. That's actually on ZFS, which compresses things automatically on file systems like X4, which doesn't compress things and which has big cluster sizes. A Nix packages copy might be a few hundred megabytes. And of course, like I said, this multiplies every time you make any change to this flake, so that's terrible. Because the evaluator works on these copied source trees, you get error messages that refer to the Nix store rather than to the original location. Now, often there might not really be a sensible original location, because if, say, you're using a GitHub flake, that flake didn't exist in your local file system anyway, so it's not really clear what sensible error message it should give, but an error message that just says /nix/store/hash-source, yeah, good luck figuring out what flake that actually is. So this is not very user-friendly. But in the particular case of when you're hacking on a local Git flake, if, for example, you add a new source file, but you forget to Git add it, it won't be a copy to the Nix store, because Nix tries to be sort of hermetic. And so you get a mysterious error message. You get no such file or directory, and you're left scratching your head and thinking, but this file exists in my repository, so what's going on here? So because I was lazy, but the underlying reason is that Nix wants to ensure, yeah, reproducible and hermetic evaluation. So that was actually one of the main goals for flakes. So in the pre-flake days, if you had your project, you might rely on the Nix path environment variable to find Nix packages, and then if two developers clone this repository and they both try to build it, they might have a different version of Nix packages on their Nix path. So they get a different result, and that is what we really wanted to avoid. So Nix was good at ensuring reproducible builds, but it wasn't very good at ensuring reproducible evaluation. So the easy way to ensure that evaluation was unaffected by any sort of, say, pollution you might have in your Git work tree, like unadded files, or that you have references to outside of the tree, like .. / some file, .nix, was to just copy everything to the Nix store. Yeah, that was pretty easy, but it doesn't scale. So the better solution is something called lazy source trees, which I've been working on for a while. It's in a pull request. It's ready for review now, so everybody is welcome to try to find bugs in this. And the main idea is to yeah, not copy source trees to the store. But of course, we still need to maintain hermetic evaluation. And we want a couple of other advantages that I'll show. Now, I'll talk a bit later about the implementation details, but the idea is that we have a sort of internally inside of Nix, there's a sort of virtual file system abstraction for accessing the source code of flakes, and different types of flakes, like a GitHub flake or a local file system flake, have different accessors that, yeah, to lazily read files like Nix expressions. So this is what it looks like in practice. So yeah, if I'm hacking on the Nix packages flake, so a Git work tree, yeah, now a Nix build, yeah, is a lot faster, 0.2 seconds. So it's not copying the Nix packages flake to the Nix store anymore. Okay, great. So that's awesome. So what does this mean? Well, let's look at the REPL. Let's fetch a tree from GitHub, namely the patch elf repository. So here you with pre-lazy trees. So fetch tree no longer returns an attr set with a out path referring to the Nix store, but instead it has this sort of magic value, which is actually, if you print it in the REPL, it will say, yeah, GitHub :nixos/patchelf/ a particular revision /. So this magic value actually, yeah, is a reference to I mean, so it provides provenance, so it knows where it came from, so it can provide useful references. But so this out path is yeah, an internal value, like I said. So nothing gets copied to the Nix store unless you ask for it. Now, if I do something like add the string /readme.md, I get a value that represents the file readme.md inside of that source tree, which is still lazily fetched. So still nothing has been copied. Now, only if I do something like an anti-quotation, like string, so quote $3, so if I'm trying to pass something as an input to a derivation, well, then the derivation, of course, needs to be able to read the source tree, so it needs to be in the Nix store. So then it will get copied. But if you don't do that, then it doesn't happen. So now, since we now have all this provenance information, so we know where these path references actually came from, we can get better error messages. So, for example, if I try to do this Nix build on, so I created this file, my package, but I forgot to git add it. So it will actually say that. So it will say access to path is forbidden because it is not under git control. Maybe you should git add it. Or if it really doesn't exist, then it will say that. It will say path, my package does not exist in this Git repository. Yeah, so much nicer error message. But also in stack traces and user thrown errors. So for example, if I have a NixOS configuration where I'm referring to Steam, which is not allowed. So previously I would get an error message like package Steam in /nix/store has an unfree license. And now I get package Steam in GitHub NixOS /nix packages /revision, blah, 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 has an unfree license. So yeah, this is much nicer. Okay, but that's not all. We now have a built-in.patch operator, which takes a source tree, which is lazy, and applies some patches to it, and returns a tree that is also lazy. So previously, if you wanted to, for instance, patch Nix packages, well, first you need to materialize Nix packages to disk, which takes a few hundred megabytes. And then you need to apply a patch, and then that gets copied to the Nix store, so it takes another few hundred megabytes. So this is very slow, and it takes a lot of disk space. But this operation, yeah, since it takes a lazy source tree and returns a lazy source tree, it doesn't materialize anything to disk unless you ask for it. So yeah, so here I have this patched, which is source tree that takes the patch elf source tree and applies a patch to it. I'm using the word patch too often here. Maybe I shouldn't have used patch elf as an example here. That gets a bit ambiguous. Yeah, and then when I do built-ins.read file to read a file from that source tree, then it will actually look whether it has a patch that applies to that particular source file and apply it in memory. Yeah. All right, now a little bit about the implementation, how this works, because that actually has something to do an absolute path in the local file system, but they are tuples of input accessor, comma, path. And an input accessor is this thing that refers to, for instance, a GitHub repository or a Git repository or Mercurial or whatever. And the path here is the path underneath that source tree, so in that flake usually. So it has a bunch of operations on this app file system abstraction, like, for example, read file, which, yeah, given one of these paths inside this flake will return a string. Yeah, and there are a bunch of implementers, like there is an input accessor for the local file system, for zip files, for applying patches, yeah, and a couple others. So, for example, suppose I'm evaluating something from the local file system, but not a Git work tree, so just a path flake. That will use the fs input accessor with the top of my flake as the root. And fs input accessor applies access control. So if you try to do .. to escape out of the root, that doesn't work. Yeah, this ensures that you cannot gain access to something that is not part of the flake. Git work trees are actually also implemented using fs input accessor, which also has a feature of, it has a set of files that you're allowed to access. So in the case of a Git work tree, that is the files that are under Git control. So if you try to access a file that doesn't exist, it can give you a useful error message. That's how it's implemented. Now GitHub repository, so here there's a big change. So GitHub flakes used to be implemented by downloading a tarball, unpacking it, and copying it to the Nix store. Now it downloads a zip file, and it doesn't copy it, or it doesn't unpack it, and it certainly doesn't copy it to the Nix store. So there is a zip input accessor that will directly extract files from the zip file. And the reason for using a zip file instead of a tarball is that zip files are random access and tarballs are not. So this saves a lot of disk space and CPU time depending on your system. All right, and similarly, there's a patching input accessor that wraps an arbitrary accessor, so for example, if you do a read file operation, it will call the underlying read file and then apply a patch to it. All right, so this does have causes some incompatible changes. The main one is that flake log files no longer have a nar hash attribute, at least not for all inputs. This is a backwards compatible change. So if you have a flake with a nar hash attribute in it, that still works. But if you take a new flake and try to run it on an old Nix, it will complain about a missing nar hash attribute. And the reason is that computing the nar hash attribute is too expensive, because by definition that requires the entire source tree to be read, and that of course was the exact thing that we were trying to avoid. It now relies on other attributes to lock the input, like the Git revision. There are some other incompatibilities, so it's not super likely that you run into them. So for example, path values, since they no longer necessarily have a representation in the local file system, toString no longer necessarily gives a useful result. So if you do something like toString tree, and tree is not a local file system flake, then you get something like _virtual. Yeah. Have sort of non-flake code, if you're not using fetch tree. And since both of those things are experimental, we can sort of get away with changing the behavior here. And similarly, so there's a breaking change that occurs kind of frequently, but we're working on a fix for that. But since flake inputs are no longer in the Nix store, lib.isStore path will return false, whereas previously it returned true. And even though it can be coerced into something that is in a Nix store, if you're doing this as a type check, as certain types in the NixOS module system do, it might break. Okay, that's what it currently does. There are some future improvements, like so Git repositories are actually still copied to the Nix store, except when you're using a working tree. But so in the future, maybe we can use libgit2 in the same way as we're using libzip. Yeah, that would be very nice. And yeah, other than that, yeah, should merge it. Okay, that's about it. Any questions?
Good. Ah, there we go. Are there questions? Oh, wow.
So one question I have is these virtual, like the virtual path kind of types, are they going to be unique or because you had like virtual dash 4 or something, right? So for two different previously store paths, will you have unique unique virtual paths?
Yeah, so I guess the underlying question here is this completely reproducible? And currently it is not. So that number 4 could actually be something different. So I have actually some ideas about it, or I had an idea and then I forgot it. But
as a follow-up, during one evaluation, will they at least stay unique, or
yes,
no, just
yeah.
not over evaluations?
Yeah.
All right.
There's 2 in the group here. So without the NAR hash, but with Git revisions, for instance, it's relatively easy to get hash collisions, right? Won't that mean that you can no longer guarantee that if 2 people build it with the lock file, you'll actually get to see the same thing? I mean, it can have a Git repo that produces something with a Git collision, right?
I didn't entirely hear it, but it's about the NAR hash, and can you still guarantee that it's the same thing?
Yeah, because we're using SHA-1 for Git revisions instead of SHA-256 for NAR hashes, right?
Say again?
So it's easier to get a hash collision with Git revisions, right?
Right. Yes, it is. Yes, that's true. And I would sort of say that's a problem for Git to solve. So maybe maybe they're going to switch to something else. I understand they've been thinking about it for 10 years or so. But I mean, if it's good enough for Git, it's sort of good enough for us. So maybe we can still have a flag to really force locking by having a NAR hash there. Because that actually has some other useful properties, like it makes the source tree substitutable from a binary cache. Without the NAR hash, you cannot substitute it anymore.
Okay, is this the last step before removing the experimental flag?
No, for that we should do an RC. Yes.
So I haven't taken a lot of questions from this side, I'm sorry. So I will now.
There is an evaluation cache for Flex that allows you to like bypass the evaluation and just fetch from the database the result for some attributes. Can you restore that feature with the lazy file system, or can you just disable the lazy thing and force to upload everything so that you have all of the hashes and you can still access that evaluation cache?
I heard part of it, so it was about the evaluation cache, and I mean, so the evaluation cache still works.
How does it work if you don't know if like the inputs are the same?
Oh, well, I mean, using the same mechanism as log files, so the top level flake should be locked in some way. But if you have right, so you don't get evaluation caching on a dirty Git work tree, but that was already not the case. Well, that's sort of similar to this NAR hash issue. So maybe you could have a way, an attribute to force locking. Yeah, in principle, yes, that is possible. Yeah, so you could have a clean Git tree, and then you start modifying after Nix has determined that it's clean. I think that falls under the don't do that category. Yeah, actually, yeah, you're right. But in that case, at least the nar hash would still reflect the sort of the dirty state, the one. Right.
Thank you, Ilko. I put away the mic already, so I'm sorry.
All right. Thank you.
Thanks again very much, Ilko. I would like to call Brian and Ron on stage.
1, 2, 1, 2. Yeah, seems to. So we're going to do the closing remarks and notes for this first day of NixCon. So thank you all for coming, thank you all for enjoying, thank you all for sharing and all that. We have one event left tonight, which is the social event that a lot of you wanted to attend, which is a jazz concert. There is some kind of story behind that. So the guys who are going to do the jazz concert, some of them are like mathematicians, and they do a lot of category theory. And one of them tried to do some sort of song about NixOS. I think it's called Reproducibility Hell or something like that. I don't recall. But yeah, you will see about it. So more logistic aspect of the jazz concert. So we're going to ask you to leave this venue so you can go have a dinner, go have something. We should start the concert around 6 p.m., 6:30, around those hours. Don't be late, please. Watch for further updates on Matrix if you are on that. And we will have to have your name or some sort of proof that you bought the social event ticket. The filtering is your badge is not in. And that's
9 sharp. I think I'm way over. Okay. 9 sharp. So we're going to start the talks. Just kick it off. We want to make sure that we're just appreciative of all of your time, and we finish when we want, when we said, and have lunch when we said. So try and be here like 8:40 max. We posted a thread on Discourse for Q&A beyond this. So all the speakers are going to be on the Discourse, of course. Ask your questions, give your feedback. I don't know, share some like wow moments that you had, and make us all happy.
Don't forget your badge for tomorrow. Don't throw it. We don't have a second one. And you will go through the door directly. You don't have to do the check-in like the first day. For you, had yes, a lot of people was asking us begin. So we would like to encourage you to take more the second option because the meat option and the fish option were exhausted quite quickly, and we had leftovers for vegan. Tomorrow we're going to do something special for the lunch. We're going to do a zero waste lunch. So it's a more complicated way to have a lunch. Reusable, like there's going to be reusable containers and stuff like that. So please be careful. Do not throw anything. Like if you have any glass, something that you can reuse, put it away and give it to us so that we can be paid back €1 per container. Otherwise, we will have to pay extra. And so that it's really zero waste and it's great for the planet. So please be careful for tomorrow regarding this.
So a few other last tidbits before we let all of you go. One is that tomorrow, when you're doing social media, Twitter posts, helping kind of push, we talked about marketing, like hashtag NixCon, Nix, tag, so get into one. Just a reminder, we do have masks available. COVID's still a thing. If you feel like you want to get tested, I mean, to each their own, feel free to do so. There's dispensers for alcohol gels across the thing. Use them. And I think last thing is tomorrow is going to be the hiring happy hour. So just a quick reminder again about that. We're all going to be talking and mingling. The folks with green dots on their badge means that they're hiring for roles. Feel free to approach them, ask them what's going on, and just talk. And I think
maybe some more logistics. Today we had a lot of delays and it's quite complicated. You all had the right reaction to that. Between each talk, you took a break, took a drinks, whatever. Tomorrow we are trying to stick to the schedule, so we will have separated break. I encourage you to not have a break between each talk because it's a bit complicated for us to manage. There are people who have to stay there and they cannot enjoy the talk and so on and so forth. So let's stick to the break for having a drink, if possible. And you have to know also that we don't have any more Club Mate. We're out of stock. So we only have juice and fancy hipster drinks for tomorrow. So thanks for your heart rate, or yeah, there's still coffee, so you won't be missing on that. And finally, for the social media and pictures in general, don't forget to respect the linear color. If it's black, don't share the picture or crop the picture or blur the person. Please, please, please honor this. And finally, I want to thank everyone, as always, the sponsors, the volunteers, the people who couldn't come, the people who helped, the people who made the food, the people who put the tent this morning where you were having a lot of fun here. And yeah, I'm forgetting someone.
I mean, wrapping up the first day, don't ruin Paris, right? I mean, I know Nixers have a tendency to party, so keep it calm this evening, but do share where you're going, right? Like share the pubs, the bars, wherever you're going, and if you feel like it on the Matrix, and I'm sure we'll start bringing it all together. Awesome. What was that? Yeah.
I have one more question.
Oh, you have it.
So I'm going to come up. I'm sorry.
Yeah.
I'm going to steal the show. Was everybody excited today? Yeah? Nice, nice, cool. Is everybody excited for tomorrow? Nice. Okay, cool. Thank you very much.
That's all. Thank you.
We're still doing